Hi students, welcome to Vedantu JEE English. I am Diksha Kaushal, your chemistry master teacher. And students, today we are going to do GOC, General Organic Chemistry. Right? So this is a very important thing, right? Because it forms the base of your organic chemistry and you can easily expect 7 to 8 questions just from GOC. Yes, you heard it right, 7 to 8 questions from today's lecture. Right? That is a huge number of questions from one topic which is also simple. It's not a very complicated topic. It's just that if your concepts are clear, you can easily guarantee that all the questions that you will answer will be correct. Right? So, firstly, how I am gonna proceed with this particular topic? Firstly, I need your advice with that. So first thing is what I have seen in students, what they are like, I want to solve the questions, ma'am, questions. But the concepts are not clear, bro. The concepts are not clear. So what I have come up with, the handwritten notes, right? My own handwritten notes. We will study from them. We will see the summary of inductive, aromatic, and resonance, hyperconjugation, these four effects, right? After that, you're going to learn one rule, that is Barhi. Now, from Barhi, you will be able to answer acidity, basicity, stability of intermediates, all the questions, right? After we are done with this handwritten notes and revised everything from here, then we will jump to the previous year questions, as you can see here, right? Then we will start with the previous year questions, but previous year questions you will only be able to understand if you know the core concept here, right? Okay, everybody, so shall we start the session? Everybody in the comment section, shall we start the session? Yes, everybody. Okay. Welcome Raghul, BSO4. Oh my God. Okay, BSO4, I'll talk less. Okay. Chalo. Now let us start with the electromeric effect. So first thing is electron displacement effects, right? So electron displacement effect, you know, the questions has been asked from which is a temporary effect, which is a permanent effect. This is your JEE, I think 2024 question only, right? So those many basics also you need to know. So first is temporary effect is electromeric and inductomeric effect. Inductomeric effect is not in your syllabus. Electromeric effect is in your syllabus. So we are going to study electromeric, and one to two questions has been asked directly on electromeric effect also, right? Then the permanent effect are inductive, hyperconjugation, resonance, or mesomeric effect. These are your permanent effects, right? So we are going to study about all these effects in detail. First thing is we are going to study about inductive effect. What is a inductive effect? So guys, if you talk about the inductive effect, right, these are I have shown the definition of temporary and permanent. Temporary effect is which depends on the reagent. Now here we can see that basically here when the reagent, that is Cn negative, is attacking on the pi electrons, then the pi electrons are moving here, right? At that place, that means they are, for example, you are studying only in the presence of someone like some teacher or your parents, then you are temporary, right? But if you are studying whether someone is present there or not, you are doing your study, it doesn't matter to you, then you are permanent. That means it doesn't matter. If you talk about the inductive effect, in inductive effect there will not be any outside reagent which will cause the dispersion of electrons, right? Here it will disperse by itself by the electron negativity, right? Okay, so this is your permanent effect. This is temporary effect. Here I have taken the example where there is reagent and pi electrons are moving here. This is basically the example of electromeric effect that we also study. We will study that, okay? And this is the example of inductive effect. So inductive effect is basically dependent on the electron negativity, right? So if you talk about the electron negativity, this is the inductive effect. First thing is, now if you have C and C, it does not have any electronegativity difference. So there will be no inductive effect here. But if you have C and X, there is electron negativity difference that you can see, because halogen is more electron negative as compared to carbon. So we can see that the electrons will be more towards the halogen, and this is called the inductive effect. That is why this group is going to take out the electrons, right? Okay, now the CC bond in ethane has no polarity. It connects two equivalent atoms with identical electronegativity. This is what I explained you, that CC in ethane, which has no electronegativity difference, so there is no inductive effect there. Now, what exactly is inductive effect? If you talk about 2-3 statements they can give you. First is distortion of electron. That means the motion of electron. Yes, it is the distortion of electron. Second is the distortion of pi electrons. No, it is the distortion of sigma electrons, not the pi electrons, right? Displacement of sigma electrons, yes. Delocalization of sigma electrons, no. So this is basically redistribution, distortion, displacement of sigma electrons, not the pi electron. And delocalization is a different concept that we will use in resonance, not in inductive effect, right? Okay. Now, as you can see here, what is this? This is basically the polarity that I am telling you. C and C, they don't have polarity difference. So the electrons, we know that electrons are not static, right? They are moving. So electrons will be moving in this particular domain. But if you talk about electronegativity of X, that is more. That is why electron will be more towards this X. That is why they will distort from their position. That is called distortion of electrons. Okay. Now, what is this? Everybody, what is this? Now, as you can see here, this is basically the displacement that I want to show you. This is C and H. This is C and electron donating group, isn't it? Now, C and H has electron somewhere here, because carbon is more electron negative as compared to hydrogen. But for example, you have some electron donating group, which is donating the electron, it is not taking away the electron. That is why the electron will be displaced towards the carbon. So hence this delta X is your displacement, right? What about if you have electron withdrawing group? If you have electron withdrawing group, they are going to, earlier you had electrons here. Now because of electron withdrawing, the electrons are getting to this place. Now that is why the electron got displaced from here with the delta X, right? That is called displacement of sigma electrons, right? Okay. Now, next is relative effect or permanent effect. What do you mean by relative or permanent effect? Relative, these are the, they can ask you the statement, which of the following is true for inductive effect? Any of this statement they can give you, right? That's why. Now, relative effect or permanent effect, right? That means it is a permanent, or it depends on whether there is halogen or what is attached. So it is relative effect. Reference is hydrogen, inductive effect is 0. So we are saying that, like when we calculated the calculated the reduction potential, we took SHE, standard hydrogen electrode potential, as 0. So similarly, here we are taking reference as hydrogen, which has inductive effect as 0. Due to electronegativity difference, it will occur. It is unidirectional. We know that the one which is more electron negative will have more electrons. It's not like electrons will move here also, here also. Electrons will move only in that direction which is more electron negative, right? Next is irreversible effect. Now this effect is not, that means we can't say that this is Cx. Once the electron has moved here, the electrons can also go back. No, right? So it is a irreversible effect, right? Now, next is with distance, how it is varying. Now distance also, some questions of your JEE are asked based on this concept, right? So as we move away, the inductive effect will decrease, right? So decrease the inductive effect. As we, for example, this will have less inductive effect, this will have even less inductive effect. So as we move away from that halogen or that electron donating or withdrawing species, the inductive effect is going to decrease with the distance, right? Okay. Now, next is in gold conversion. So basically because of in gold, you have two things. One is plus I, next is minus I. Now the order of plus I and minus I and the groups that are showing plus I and minus I are very important for you. Directly the questions are asked from that series only. So plus I effect is electron donating, right? Sigma electron donation they are doing, right? So electron donating group, and minus I is electron withdrawing group. Electron donating, usually it will be alkyl species. Alkyl means CH3 or any alkyl group, it can be present there. Minus I, usually it will be the one which is more electron negative, the one which is carrying the electronegative atom, that will show minus I effect, right? Now, next is electron donating. This is whole series of electron donating, that is plus I series. You can take a screenshot of this. Notes will also be provided to you, right? The maximum is for CH2, then you have NH, then you have O negative, COO negative, then you have 3 degree, 2 degree, 1 degree, and in 1 degree also methyl will have lower effect as compared to ethyl. Methyl will have lower effect as compared to, this is very, very important, okay? This thing is very, very important. From here the questions are asked to you, right? Which is having more plus I effect. 3 degree, then 2 degree, then you have 1 degree, right? Because each methyl group is going to give plus I donation here, right? Then from this, what is T, D and T, H? This T is tritium, the isotopes of hydrogen. Then you have deuterium, then you have hydrogen. Tritium have the maximum TDH, TDH. Okay, got it? Yes, everybody, till here any problem? Guys, any problem till here, right? Okay. Vijay, do one thing, because I am not like writing anything. I am just recapping everything here. So go through the concept once, right? After that, we will solve the previous year questions also, right? Okay. Yes. Which thing you want me to explain, right? Which thing you want me to explain? Yes, bacha. These I have included everything from GOC, okay? So electron donating means the one which is donating the electron. You are giving the electron, right? For example, you have some bond, this is some A and this is B, right? If A is an electron donating group, it will give the sigma electrons to this B, right? Sigma electrons will be more towards this B. That is electron donating. Now, this is very important to note electron donating groups. At 3 degree, then 2 degree, then 1 degree, then you have methyl, right? Okay. These are the isotopes of hydrogen, okay? These are the isotopes of hydrogen, first, second and third, right? This having 0 neutrons, 1 neutron, 2 neutrons, right? So, these isotopes of hydrogen, they will be given to you, right? So, this tritium has the maximum, then you have deuterium, then you have hydrogen, right? That is the first isotope, that is having the minimum plus I effect. Got it? Okay. So, this is your order of plus I, right? This is the order of plus I. You can take a screenshot of this. This is very, very, very important, guys. Now, next is factors affecting. Now, what are the factors that are affecting this thing? Factors is for affecting plus I group are anion are showing more plus I effect as compared to neutral. So you can see here, why can you tell me why anions are showing more plus I effect? See, it's about donation. The one who is rich will be able to donate more, right? So negative means they already have extra electrons. That is why their donation power is more. That's why we are saying more the anion, that means more the negative charge, more is the donation power, right? Now, next is branching. That means more is the branching, more is the plus I effect. So, as you can see here, here you have 3 branches. You have this kind of thing, C, C and then C. Here you have 2 branches. This is one C and this C. Here it is having only 1 branch. Here there is no branching. That is why more is the branching, more is the plus I effect. Next is, if branching is same, if I am saying the branching is same, just like in this case. Here, there is no branching. This is also primary, this is also primary, right? So, if your branching is same, then plus I is directly proportional to number of carbon. So this concept is very, very important, and based on this also the questions are asked. Anion has more plus I effect, then you have more the branching, more the plus I. Third is, if you have same branching, all of them are secondary, all of them are primary, then more is the number of carbon, more is the plus I effect. Got it? Okay. Got it, guys? More is the plus I effect, more is the number of carbon. Right? Okay, chalo. Now let us see some questions here based on this, like what kind of questions they can ask you. Now, first is CT3 is greater than CD3. Here I am telling you the plus I order here, right? Everywhere I am telling you the plus I order. These things will help you in solving the questions, okay? So first thing is, if they give you TDH, always T is going to have more, then you have D, then you have H. That is the order of plus I effect, right? So T is having more, then D, then H. Here, what we can see in the second statement, we can see 3T, 2T, 1T, 0T, right? T is having more plus I effect. Here you have 3T, that is why it will have maximum plus I. 2T, less than that. 1T, even less than that. No T, minimum. Got it? No T, minimum. Got it? Guys, everybody, Bacha, are you able to understand or not? Hanji, everybody. As though you were saying, Acha, there is some ting 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 going on. Hanji, everybody. Do you want to only do the questions, or do you also want to see the concept? If you are only interested in the question, then also let me know in the comment section. Then I will not explain you anything. I'll just explain you the questions here, right? So what do you want? Because your exam is very near, so I want to know that what you want. Do you want a revision, or do you not want any revision? You just want to see the questions here. Hanji. Chalo. Now, next is, this is SP, this is also SP. Third is very important, okay? So these are where your JEE questions, right? They can ask you questions from these kind of things. So now, here they are saying that this is CH3, right? CNH2. Now, this is your SP, this is SP, this is SP3, this is SP3. We know that. Now, they are asking that which concept is right. Okay, which concept is right? The electrons will be donated from this side to this side, or electrons will be donated from this side to this side. Which concept is correct here? Now, for that, simply they can ask you this question directly. You need to understand this concept here, that sp3 is always less as compared to sp. Can you tell me the reason behind that? See, if you talk about sp, sp2, sp3, sp, sp2, sp3, right? These three things if you talk about, here you need to understand one thing, that more is the S character, more is the electron negativity, right? Okay, that is the reason. If you talk about here, you have maximum S character, so this is maximum electron negativity. It has minimum S character, that is why it is having minimum electron negativity, right? So here we have written that this is your order of electronegativity. This is having more electronegativity as compared to this. But students usually get confused here. They're like, okay, ma'am, this is having less electronegativity as compared to sp, right? So, ma'am, what will happen? Electrons will go to this side. Okay, electrons will go to this side because this is having more electronegativity, right? Now, one more thing you need to remember. NsP3. If you have nitrogen and it is sp3, or you have carbon and it is sp, in that case nitrogen having sp3 is having less electronegativity as compared to carbon having sp. Okay, basically we know that usually what is the case, this is the case, more the S character, more is the electronegativity. So here also we are going to apply the same concept, that here nitrogen having sp3 is having less electronegativity as compared to this carbon having sp. So basically what I want to tell you here, usually students feel that ma'am nitrogen is more electronegative as compared to carbon. So ma'am nitrogen should take out the electron. If you see only the atom, then you will say ma'am nitrogen should take out the electrons ma'am, because nitrogen is more electronegative. I am saying that here you don't need to look into the nitrogen and carbon, because here we are looking for the hybridization. More is the hybridization, more is the S character, more is the electronegativity. So here we will not focus on nitrogen, we will not focus on the carbon, we will focus on sp3 and sp hybridization. Sp hybridization is more electronegative, it is going to pull the electron towards itself. So electrons will be given from N to carbon, right? Okay, from from more electronegative to less electronegative atom, we are giving the electron. It's a very, very important question, right? Very, very important. Got it? Right? Okay. Okay, guys. Understood? Chalo. Now, let us see the next concept here, right? This is your minus I order trick, right? This is your minus I order, right? So maximum, this is for NF3, then you have NR3, then you have NH3, right? Then you have NO2, SO3H, CnCHO, COH, fluorine, chlorine, bromine, iodine. Then you have oxygen with this phenyl ring, COR, OR, COR, SH, SR, OH, triple bond, NH2, phenyl, CH, double bond R2. So this is your minus I. Usually they will ask you questions from, first thing is this one. Okay, from here they can ask you the question. Second thing is they can ask you the order of N to NO2 with CN. Usually these questions are asked with halogens, or yes, and sometimes they also give you COR also, right? And between this is a very 2-3 questions are very important here. Okay, first is NF3s. Directly they will ask you the question, which of the following is correct order of minus I? This is the concept behind that, right? So first thing is from this order. Next they can ask you that OR is very, very important, is having more minus I factors compared to OH, but also SH is having more minus effect as compared to SR. So these two things are also important. Okay, these two things are also important for you. First is NF3, NR3, NH3. Then you have OR is greater as compared to OH, but SH is greater as compared to SR. Okay, got it or not everybody? Chalo. Now why I asked you this, from here a assertion reasoning question can be asked, a very, very important question, right? So first thing is, we are saying that hydrogen, this is R2, this is NH2R, and this is N positive R3, right? Okay, understand this concept. It is little bit tricky, but it is very important for your JEE, very important. Okay, now see this. First is you have N positive. Let's draw the structure. We know that NH3 is a tetrahedral structure, so I have drawn the tetrahedral structure of all of them. N positive 3 hydrogen, N positive 2 hydrogens. Wait a minute, here you have 1 hydrogen, 2 hydrogens, 1 R group. Then you have 1 hydrogen, 2 R group. Then you have 3 R group. Right? Now, what we are going to do here it should be NH2R and it should be NHR2. Okay? It should be NHR2. Let me correct it here. Chalo ji. Now, ma'am, what's the big deal in this? What's the big deal? I'll tell you what is the big deal. What they can ask you directly, and a predictable question, okay? So, first thing is, ma'am, why this order? Ma'am, why this order? I told you more is the alkyl group. See, hydrogen has 0 inductive effect, but alkyl group is showing donating effect. It is showing plus I effect. So, that means always remember one thing. Positive means we are talking about money, paisa, money. So when someone doesn't have money, they are deficient of money. You give them money, they will become very happy. है ना? For example, I don't have money. So you say that, ma'am, I can give you money. This is, you take this. I'll become happy. है ना? So when you have electron deficient species, so when you give them electron, they will become stable, right? So here, what will happen? So what we are going to do here? Now, if you talk about these four things here, here what we will see, this is R, है ना? It is donating the group, है ना? It is donating plus I. It is also donating from 2R group. It is donating from 1R group. It is not having any donation. So if you talk about the plus I order, right? The plus I order, right? The plus I order will be maximum. It should be like this. That it should be maximum in NR3, right? Acha, we are talking about minus I order now. Okay, I'll tell you how to see from plus I how we will jump to the minus I order. Now, when you are giving them, for example, someone is very poor. Okay? Someone is very poor, very poor, very poor, very poor. Now, he has 3 friends who is giving him electrons. Don't look at this. Don't look at this. Just understand what I am telling you. Okay? Poor, 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 poor. You 3 friends are very rich, like our group. They are donating the electrons. They are like, now I am not electron deficient. है ना? That means now this will not be so much electron deficient, and it will try to pull out electron from someone. For example, someone is doing bank robbery. The person might be very poor. They are a thief. The thief, I'm not saying thief, like the one who is a thief, he is a good person. No, I'm not saying that. But I'm saying that the one who is actually coming to your house and, taking out something from you, there must be some kind of majboori, na? There must be something. For example, someone out there is begging, na? They are begging for food also. Why? What's the need, right? If you don't look into any trap or anything, someone is asking you for one chapati, for one roti, that means they are very poor, right? So now, this is very poor. You are giving the electrons. Now, this is stable. Now, earlier though, when you are very poor, then you will try to take out electron from someone. But now, this is not poor. So, it will not try to take out electron from someone. So, the answer should be this should be that N positive R3 should have minimum. Now, here, 2 friends are giving the electrons. So, here, its electron deficiency will decrease also, right? So it will be NR2H, this is positive, right? This is N positive H2R. Here only one friend is donating. It does not have, NH3 has no friend who is donating any electron. That is why NH3 is having the maximum minus I effect, because no friend is donating electrons to NH3. So NH3, this N positive, no friend is donating the electrons here. So this N positive is feeling very lonely, right? So that is why they want to take out electron from someone. Firstly, tell me, is that thing clear to you? That why I have drawn this particular sequence here? This is NR3, this is this. Firstly, so you should know what is the correct and how we need to correct it. This should be the order. But in reality, this is the order. This is having the maximum electron deficiency. That means, why this nitrogen is having 3 friends who are donating electrons, still this nitrogen is very hungry. Still this nitrogen wants to take out electron from someone else also. That is very important, and this is what I was telling you is a very good question of your JEE. They can ask you this question based on this concept, right? So here how we will answer, basically we will compare NH3 positive and NR3 positive. Why this is having more minus I effect as compared to NH3? What is the reason? It is having 3 donations here. It should have less minus I effect, still it is having more. Reason is the bond angle here. As you can see, electronegativity order is sp, then sp2, then sp3, right? That is the order of electronegativity. If you talk about the bond angle order, we know that sp linear shape, sp2 trigonal planar shape, sp3 tetrahedral shape. This is the bond angle order, right? Now, more is the electronegativity. That means we can say that electronegativity is directly proportional to the bond angle, right? So here can I say that here if I see the bond angle here will be more. Can you tell me why the bond angle will be more? Can you tell me that? From here I have taken out this particular I would say connection relationship between electronegativity and bond angle. That electronegativity is in the same order, bond angle is also in the same order. Can I say bond angle is directly proportional to the electronegativity? That means here we know that because of steric repulsions, because of these three big R groups, there will be repulsions. Because of repulsions, there will be bond angle will increase here. So bond angle will increase. That is why electronegativity will increase here. Electronegativity is more. That means the minus I effect is more. Okay. So this is the exceptional case. That is why I have taught you this here. Okay. So all the exceptions I want to teach you, because from exceptions only the questions are asked. Students, tell me, is that clear to you or not? Is that clear to you or not, guys? Is that clear? Chalo. Now, let us talk about a very important concept, that is carbocation and carbanion. Now, from here, just remember carbocation is like money. When someone is poor, you donate them money, they will become very happy. You take out money from someone who is very poor, they will become very unhappy. That means unstable. Opposite is for carbanion. Carbanion is like stress. When someone is under stress, you give them more stress, they will become unstable, they will become unhappy. Someone is under stress, you are taking out stress from them, they will become happy, they will become more stable, right? These two concepts will solve so many questions of your GOC, so many questions. Okay, now here I think, do you want to do the questions also or not? Guys, do you want to do the questions here or not? Everybody. If you want to do the questions, then I'll just do that in a very quick manner. We'll do the questions, okay? Because there are around 15, I think around 20 questions from here. These kind of questions are only asked in your JEE, right? Okay, so I'll just quickly summarize all the things for you. Now here, this is the alkyl and this is the alkyl group. More is the number of carbons in the alkyl group, more is the plus I effect. So here, this is the carbocation. We know that here more is the plus I effect. Now someone is very poor. You're donating more money to them, then they will be more happy. Here this is also poor, but here donation is less. This CH3 is donating only 10 rupees, but CH3, CH2 is donating 100 rupees. So 100 rupees will be more stable, right? So that is why A is more stable as compared to B. Second question is, when you have fluorine and you have chlorine. Now, here we will talk about the electronegativity. We know that fluorine is more electronegative as compared to chlorine, right? So, when someone is positive, right? Now, what we will do, we will take out the electrons, right? We will take out the electrons from them. Someone is already very positive, very means electron deficient. You are taking out the electron with more minus I effect, that is fluorine. That is why it will be very unhappy. That is why this will be more stable. B is more stable to A. Reason is guys, because chlorine is having less minus I effect. Is that thing clear to everybody? Chlorine is having less minus I effect. That is the reason it is having more stability. Just remember, someone is poor, you are taking out electron with less efficiency. Here you are taking out electron with more efficiency. So that is why this is unstable. Next question on your screen, it is, you have A, B, C. Same thing you have, but here you have fluorine, chlorine and bromine. We know that fluorine is having maximum, then you have chlorine, then you have bromine. This is the electronegativity order. That means fluorine is a very bad friend. Fluorine is, you are already poor, he is also taking more money from you. He is a bad friend, enemy. Fluorine is your enemy. So fluorine will make it highly unstable. That is why A is least stable here. If you talk about bromine, it is also a bad friend, but not as compared to fluorine, it is a better friend. That is why it will also take out the electron, but with less efficiency as compared to fluorine. So then you have here C, right? Okay. Fluorine, अच्छा chlorine है ना, उसके बाद तो it is chlorine, हाँ. Fluorine, then you have fluorine, then you have bromine. Fluorine has a maximum electronegativity, so it is highly unstable. Then you have chlorine, which is also taking out the electron, but with less efficiency, so it is then B. Bromine is good friend here. He is also good friend, I would say. He is also taking out the electrons, but as compared to chlorine and bromine, its electronegativity is less. So it will take out less electrons here. That is why among these three, C is the most stable here. Okay, right? Okay, chalo. Got it? Now, here we will see some questions which will be little bit tricky for you. Not even tricky if you know the concept, that it will be easy for you only. Right? This is Cl, this is F. Now what you will see here, that here ma'am, this to same only, this to simple. No, this is also a little bit difference here. Here chlorine is at the first position. Here fluorine is at the second position. Now, what ma'am we should see? Should we see the electron negativity of fluorine or should we see the distance? Right? So that is the concept. For that, strong group but far away is weaker than weak group nearby. He is saying that if you have a very bad friend, but he stays very away from you, he is far away from you, then he is much better than a friend who is not bad as compared to that fluorine. He is like chlorine, who is not that bad, but he is living with you, right? So that friend is even like, he will ruin your life, right? So this is what they are saying here, that this chlorine here is more dangerous as compared to fluorine. Because fluorine, we know that fluorine is a real bekar person, है ना? Fluorine is like most electronegative element, but it is away from this, away from the carbocation. Here chlorine is near to the carbocation. The one which is near, even though it is weak, will have more dominance, will be more dominating as compared to the one which is far away. Here we can say which will dominate: distance. Just remember, distance will dominate. Distance will dominate as compared to strong or weak, right? So now here chlorine will have more minus I effect because of the distance. That is why it will make it unstable. So B is more stable as compared to A, right? Okay, B is more stable as compared to A. Got it, guys? Chalo. Now, next important concept here is, this is fluorine. Here you have two chlorines. Now, ma'am, which will dominate? Now, ma'am, there is no distance, but there is number is increasing. So, weak multiple group is more dominating as compared to strong single group. Fluorine alone and two chlorine. So, two chlorines will be more dominating. So, two chlorine will have more minus I effect. That is the reason here more minus I effect means it will make it highly unstable. That is the reason A is more stable as compared to B. Is that clear to everybody or not? Is that clear, guys? Is that clear to everybody or not? Yes, students, is that clear to you or not? Everybody in the comment section. Is that clear or not? Chalo. Is that clear? Chalo. Now, let us see the next concept here. Let us see the next concept. Guys, please tell me in the comment section if that is clear to you or not. Right? Here you have sp. This is sp2. This is sp3. Right? So now, why this is sp? 2 sigma bonds, 3 sigma bonds, 4 sigma bonds. More is the S character, more is the electronegativity, right? So that is why sp is greater than sp2 than sp3. That means here from this carbocation, sp is going to take out electrons with very high efficiency. But here sp3 will also take out the electron, but not that much. That is why this sp is going to destabilize it, because minus I effect destabilizes the carbocation. So that is why A is, then B, then C is the maximum stable here, right? Okay. Chalo. Now let us talk about the carbocation. Same concept, carbanions. The concept has changed now. For carbanion, what you need to see, that in carbanion, it is like a stress. More donation means more instability, right? Okay. So here what will happen? Electron withdrawing group is going to stabilize the carbanion, right? You can say electron withdrawing group will stabilize the carbanion, right? Electron withdrawing group will stabilize the carbanion. Let us see this here. Here you have 3 electron withdrawing group, fluorine, chlorine and bromine. Now fluorine is not a bad friend. For him, fluorine is a good friend. You are under stress, you are calling your friend, friend is like, hey, don't worry, I'm here only. Fluorine is that friend. Hai na? So fluorine is taking out the stress. So it is making it more stable. This is having minus I, but not that much. This is also having minus I, even poor as compared to chlorine. So answer will be A, B and then C. Right? Okay, very good. Now, next is when you have distance. Hai na? So this is A, B, C. You have NO2 group. We know that NO2 group is showing minus I effect. We have seen NO2 group in minus I list, right? Minus I, minus I, minus I. But ma'am, here distance is the variation. Ma'am, it is very near, it is far away, it is even far away. So ma'am, the friend who is living near next to my house will be more helpful to me, right? You are in problem, your bike got punctured, hai na? You don't have petrol in your Activa. So who is going to help you? The one friend who is living like in Australia or New Zealand, or the one friend who is just living next door? The one who is living next door. The condition is that friend should be good friend. So all of them are good friend only. This is all NO2, NO2, NO2. This is living very near. So it will actually take out the electron with good efficiency. So it will stabilize it. It will also stabilize, it will try to stabilize, but the distance is more. Here the distance is even more. So with distance, minus I effect decreases. Hence the stability will decrease. Hence the answer is C is having maximum stability, then B, then A. Okay? 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 Yes. Now, next is, okay. Now, next is, this is interesting question, okay? This is interesting because these are the kind of question they ask you directly in your JEE mains. Simple, direct question, okay? Now, here you have CH3, you have 2I, you have NO2. Firstly, you need to see which is showing minus I, which is showing plus I, right? We know that this is showing plus I effect. This is showing minus I and minus I effect, isn't it? This is showing minus I effect. This is showing minus I, hai na? Right? Now, let us see this. If you see this thing, the one which is donating, someone is under stress. You're like, hey buddy, I am under stress. Yeah, JEE means exam is very near. Arey, really? You are under stress? You must be under stress. You don't have good preparation. I think you don't deserve to sit in the exam. That is not a good friend, na? Giving you more stress. So here, this CH3 is giving more stress. So it is destabilizing it. So answer is A is the least stable here. Now, we need to understand from B and C which is more stable. From B and C which is more stable. Now, I told you one thing. The NO2 group is a stronger minus I effect as compared to iodine. But more is the number of groups, more will be the dominance. So here, even though it is having more distance, here the distance is less, but the number is more. That is why when you have the comparison of distance and the number will win here. So more the number of minus I groups, more will be the stability. So here B will be having maximum stability as compared to C. So here you can write number dominates. Okay, number will dominate in this case. Okay guys, number will dominate in this case. So last 2-3 questions here, very very important. First here you have, this is A, B, C. See what is the difference? Here you have one CH3, here you have one minus I, here also you have minus I, here you don't have anything. That is means this alkyl group is showing the plus I effect, right? Achha, I told you one thing. Let me know in the comment section, more the branching, more is the plus I or less is the plus I? If just ignore this part, first you have to solve between these two. Which will have the more? I know the answers are written here, but give me at least try to, recollect the information and see what you are telling me. Hai na? So try yourself also. This is having more branching. More branching means more plus I effect. More plus I effect. You are donating. Someone is already under stress. You are giving more electrons. Not happy. So that is why B will be less stable as compared to A. So here you can see B is less stable as compared to A. Right? B is less stable as compared to A. Hai na? Now, ma'am, what about C and D? Ma'am, what about C and D? This is also minus I, this is also minus I. Distance will dominate here, right? So this is closer. That is the reason it will have stronger minus I effect. So it will stabilize it more. Minus I effect stabilizes the carbanion. So this is the minus I effect. It is going to stabilize this carbanion because you are taking out stress, right? So this is going to stabilize. C is more stable as compared to D. Ma'am, how you said that C and D are more stable as compared to A and B? Because here you have minus I effect. You are taking out the stress, so making them more stable, right? Here you are giving the stress, making them unstable. So these kind of questions, very, very important for your JEE, right? Okay, okay. But these notes, they have been made from like tons of books, right? That's why I'm saying that these are very, very important books, very, very, very important books, right? Okay. You never know, out of this only you will see one question, not even one, I would say. You will see all the questions from what I am teaching you today. I can guarantee you on that, right? I have full confidence on my notes, right? So now let us see A, B and C here. This is CH3, CD3, CT3. We know one thing, all of them are showing plus I, all of them are alkyl groups, all of them are showing plus I effect. Now, this is H, this is D, this is T. We know that T is more as compared to D as compared to H, right? So more the T atoms, more is the plus I effect, more is the plus I effect, less is the stability. So C will be least stable. Then you have B, then you have A. Okay, got it? Okay, bacha, got it? Number of branching is dominated. Very good, Prachi. Very good, Ran. Very good, JEE. Very good. I can guarantee from this lecture only you will get 7 to 8 questions in the exam. Okay, and that is a big, big amount. Right? Okay, got it, guys? Now, understand, weak multiple group or weak group with less distance is more strong. Got it? This is the main key point that we have learned here. Even though someone is weak, but they are living near to your house, right? Or they are more in number. So they will be stronger as compared to the one which is at more distance or which is in less in number. Got it? Yes, everybody? Chalo. By this, beta, we have completed one portion, that is inductive effect. Now tell me if there is any problem in inductive effect, then let me know in the comment section. Chalo. Guys, if there is any problem in inductive effect, then let me know in the comment section. Chalo. Let us do the second part. Let us do the second part. Okay, shall we start? Shall we start? Chalo. Delocalization. Resonance. A concept that is applied everywhere throughout your organic chemistry that we are going to learn now. Delocalization is basically the pi electrons are moving. Pi electrons, not sigma electrons. Like the way you can see here. Here, this pi electron, here this is the sigma bond, this is the pi bond. Here sigma electrons will not move, nuclei will not move, atom will not move anywhere. Only there is delocalization of pi electrons, lone pair or negative charge. That's it. Okay. So we will see how it is done one by one. We will see. Okay. So basically, why I have not told you this thing, because I have made a proper like flow chart for you for this one to understand resonance in a very simple way. Okay. So here, sigma, pi, lone pair and free radicals. These are the four things that will show the delocalization, or you can say resonance. Sigma, pi, lone pair and free radical, these are the four things you will have. Sigma will not show the delocalization. Pi will show the delocalization. Pi electrons will move, lone pairs will move, free radicals will move. But sigma will not move. Okay. Now, let us talk about the pi electrons. Pi electrons are found basically by the axial overlapping, not axial, sideways overlapping. See, sigma are found like this. That is why the bond is very strong. Sideways overlapping is weak. That is why pi electrons can easily move here. Right? Now, lone pairs and free radical. Lone pairs is, for example, this nitrogen is having 2 electrons, but it has not gained these 2 electrons from somewhere else. Right? These are its own free 2 electrons. Free to move. That is why they are also showing delocalization. That means delocalization will be shown by that which is free to move. Right? Okay. Free radical. Free radical is caused by homolytic cleavage. Right? Homolytic means here you have 2 electrons. 1 electron will move here, 1 electron will move there, and you will have here A, here you will have one bindi. Right? Here and here you will have one bindi. And a ma'am is totally in love with free radical. That's why I always have free radical on my forehead. So here you have free electrons. Free radical, electron is also free to move. That is why it is showing the resonance. Right? Now, if you talk about benzene, this is that compound that is like showing the resonance. Right? So I'll just show you the structure of benzene here. Right? Very simple. This is how the delocalization of benzene will work. As you can see, there will be sigma bonds also. C and C will have sigma bonds. All of them will have one sigma bond. One carbon is going to have one sigma bond with other carbon and this carbon. That means 2 sigma bonds with 2 carbons. 1 sigma bond with the hydrogen. Each carbon will have the same thing. And the pi electrons, right? These are this, with this blue I am showing the pi electrons. The pi electrons, the pi electrons, the pi electrons, the pi electrons. These pi electrons are in delocalization. That means they are not sitting here and there, right? It is like sometimes this is bonding, making a bond with this one. Sometimes this is making a bond with this one. Sometimes this is making bond with this one. Sometimes this is making bond with this one. This is the sideways overlapping is happening. That is why we draw the structure of benzene like this. Okay. So that is also, we also write it like this. That means the delocalization we show. Or we can also draw the Kekule structures like this. Okay. So this is 1, 2, 3. That means sometimes the electrons will be here, sometimes here. Alternate double single bond it will show. Right? Okay. Chal. Now, next is rules of resonance, right guys? Rules of resonance. From rules and stability of resonance, so many questions are asked, right? Okay, but I am going to do previous year questions. Don't worry about that, okay? Firstly, let me revise everything that we have studied, okay? Otherwise, so it will no use of doing previous year questions. GOC does not work like that, okay? I am doing all this for your for your paper only. There is no benefit of me, है ना? I am तो even my throat is totally gone. Still, I am teaching you this thing. Why? It's not my benefit. It's your benefit, right? You are going to get benefit out of that. I'll to get tired only after standing for such long hours, right? Why I am teaching you this? Reason is I don't want you to cram the previous year question, to understand the previous year questions, right? Okay, chalo. Now let us revise everything. See, eventually you are going to revise only. You're just 1 month away. Why not to revise with ma'ams and ma'ams' beautiful notes? So that will help you. Now, rules are only pi and unshared electrons can participate. That's what I told you. Actual structure is average of canonical structure or resonance structure. Maximum number of valence electrons rules is obeyed. That means always octet rule will be completed here. Position of nuclei does not change. Canonical structure, the resonance structure have same number of unpaired electrons. The unpaired electrons will not differ. Energy of very, very important. Resonance hybrid is less than the structures. That means resonance hybrid is more stable as compared to the canonical structure or resonance structure. All atoms are planar, or very, very important, all atoms are in sp2 hybridization, right? All atoms must be planar. Okay, Ji? So now, next thing is, let us see resonance. I'll give you a simple condition for resonance. 3 kind of resonance you will observe, guys. First is double bond and p orbital. Second is alternate double bond. Third is back bonding. These 3 kind of resonance you will see, right? Firstly, let me show you double bond and p orbital resonance. Say p orbital can be of 4 types, okay? P orbital can be of 4 types. P orbital can be totally empty. That means this is the p orbital, hai na? So p orbital can be of 4 types. P orbital can be totally empty. That is called carbocation positive. If it has 1 electron, it is called radical. If it has 2 electron, it is called negative or lone pair. Now, how many of you actually know the difference between lone pair and negative charge? And what is the difference? See, this will help you in the resonance. Some students don't know how to draw the resonating structure, and I understand that problem because someone has not taught you like that. Hai na? So it's a problem of teachers also. Now, here you have 2 electrons, right? Here also it is having 2 electrons. If here I am drawing A negative and here I am drawing A 2 electrons like this, what is the difference? In this case, these 2 electrons are of A only. Hai na? But in A negative, 1 electron is for A and 1 electron it has taken out from someone else. For example, you had this kind of bond. This is your 1 electron of A and this is electron of B. They are in the covalent bond. Now from here, if A will take out these electrons and will become A, 1 electron of itself and 1 electron it has taken from this B. Now this is called A negative. Okay. But when you talk about lone pairs, that is just for A only. Lone pairs are for its own, right? Lone pair are not like it has borrowed from someone else. That is the difference between lone pair and negative charge. So p orbitals are of 4 types, either empty, either 1 electron or 2 electrons, right? Okay. Now, one by one, this is the difference that I have shown here, right? That lone pair, 2 electrons are of its own and here 1 electron is of its own, right? Now, 4 kind of resonance firstly we will see, right? Okay, 4 kind of resonance firstly we will see. First is double bond, single bond, lone pair. Okay, so let's learn how to do the resonance, how to make the resonating structures. A very, very important question is asked just to draw the resonating structures. How many resonating structure it will have, okay? So now, lone pairs, for what you will do, this is C double bond CX, lone pairs. Lone pair to bond pair, lone pair to bond pair to negative. Okay, can you tell me the reason here? lone pair are converted to bond pair. That is why there is a double bond here. And these two bond pairs are connected to, why we have not put here lone pair? Reason is, here this carbon is taking the pi electron, one is of its own and one electron is of this other carbon. So that is why we can't put lone pair here. That is why the simple trick to remember here is, remember, write one thing, lone pair to bond pair to negative. Okay, lone pair to bond pair to negative. This is how you will make the resonating structure of this double bond and p orbital, right? Okay, yes. Now, okay, chalo. Chalo. Now, but don't worry about these people, है ना? Let's not waste our time because your exam is just 1 week away. Let me just block that person. है ना? Why to waste our time on such stupid people? No, our time is very important. We are not going to waste our time because of these stupid people. Okay, let's focus here. Now, I'll just, if I see this after like 2 minutes also, then I'll block it. Don't worry. Right? Now, beta, these are the 3 examples. For example, this also has lone pair. So, always lone pair is going to donate. Lone pair will get converted to bond pair to negative. Lone pair to bond pair to negative. Lone pair to bond pair to negative. Lone pair to bond pair to negative. Now, next thing is, ma'am, why we have positive charge here? To make the electrical neutrality, है ना? Because X was supposed to make only one bond. It is forming 2 bonds. So that is why we have one positive here, right? Okay. So here when you are converting lone pair to bond pair, the one from where you have taken the lone pair, for example, someone was having 20 rupees. You have taken those 20 rupees from them. They will feel electron deficient. So that's why this X had 2 extra electrons, lone pairs. You have taken those lone pairs from it. So that is why it will feel very electron deficient. So that is why there will be one positive charge here, right? Okay. So this is a very, very important concept. Lone pair to bond pair to negative. And here you will have positive. Electrical neutrality is maintained. So these are called the resonating structures. First we have done lone pair, and that is double bond, single bond, lone pair. Double bond, single bond, lone pair, that we have done. Second case is double bond, single bond, negative. Second case is double bond, single bond, negative, double bond, single bond, negative. How to make the resonating structure here? Negative to bond pair to negative. Negative to bond pair to negative. Okay, negative to bond pair to negative. No positive needed. Reason, electrical neutrality is already maintained. And negative to bond pair to negative. Negative to bond pair, already this is also whole negative, this is also whole negative. So it is done, right? Okay. Third is double bond, single bond, positive. I told you 4 types of p orbital you will have. Lone pair we have done, negative we have done. Now we are doing carbocation. For example, your orbital is empty only, right? If your orbital is empty, so I have also made the orbitals here. If this is empty, what exactly is going to happen here? What will happen here? See, this bond pair will go and jump on this side, and from where the bond pair has jumped, that thing will have the positive, right? Earlier, this carbon was very rich. He had like fully filled orbital, very happy. So the bond, the pi electrons are not loyal, guys. Pi electrons are not at all loyal. They are just moving here and there, right? So pi electrons will move here, right? So he will be very happy that my electrons are completed. He will not be deficient. But now this carbon will be deficient here. Okay, so you just need to change the double bond to the next position and positive on the previous carbon. Okay, positive on the previous carbon. Okay, very good. Now, next is double bond, single bond, free radical. Free radical means 1 electron here, right? Okay, free radical means you have, this is empty. this was empty. That is why what was happening, this will jump here and you will have bond here and this will become empty. Something like this. Got it? Something like this will happen. What will happen here now? This will jump here, है ना? This will jump here. This will jump here. That's why you will have electrons here, right? And hence bond will be formed here and this will be your empty. This is what has happened, right? Okay, this is what has happened. But if you talk about the free radical is like sometimes here, sometimes there. It's like electron is also here, electron is also on this side, है ना? So sometimes this electron, sometimes it is making bond with this electron, sometimes it is making bond with this electron. It's like sometimes this electron, sometimes this electron, not at all loyal, right? So here what will happen, again this is same as carbocation. This pi bond will shift here and here you will have that dot, okay? That free radical will be here, okay? So here pi electron will shift here and here you will have the free radical. Got it? Okay, got it everybody? Simple. Any problem here, right? Anything in the subject because the study started without understanding, just memories. Ma'am, I need help. Just start from here, okay? Start from GOC. Start from here, right? Okay, you have come to the right channel and the right thing, right? Chalo. Now, guys, are you able to understand double bond, single bond and p orbital? Is there any confusion? Okay, I'll just conclude it here. When you have double bond, single bond and lone pair. If you have double bond, single bond and negative charge, I'm just saying taking this as A and lone pair, this is negative charge. This is double bond, single bond and positive charge. This is double bond, single bond and free radical, right? So I am just concluding this part for you here, right? What you're going to do, how you're making this resonance structure here. Resonance structure, how you're going to make the resonance structure. Lone pair to bond pair, lone pair bond pair is to negative. So this will be C double bond C, this is A. Here what will happen, pi electrons will jump here. So lone pair to bond pair, here you will have positive. Bond pair to negative, here you will have negative. What about this one? Negative to bond pair to negative. So here we will have CCA. Negative to double bond and double bond, that means bond pair to negative. This will be the second case, right? Third is this pi bond will jump here and you will have CC and this is A. Double bond will be here and here you will have positive. Again this pi bond will shift here. This is CCA. This will be the double bond. This will be the double bond and here you will have the free radical. Now guys tell me, right? Okay. Okay. Yes. Okay, bacha. Okay, so are you able to understand this? Now Sabrish, okay, I'll not speak that. Now tell me, are you able to understand this or not? Are you able to understand this or not? Yes, guys. So that is your simple conclusion. Next thing is even more simple, right? Okay. Okay. Yes. Don't worry, Minhaj, that will be sorted today, okay? You can trust me. Now, alternate double single bond. Second case is alternate double single bond, right? Again, what we will do? Pi bond will shift here. Pi bond will be converted to this negative and here from where pi bond has shifted, there you will have the positive. Pi bond will shift to the center. From where it is shifted, that will have the positive. And to where it is getting shifted is it will have the negative. Okay. So basically what will happen, here you will have the double bond and here you will have the positive, here you will have the negative. Okay, got it? So that is your double bond, single bond. If you want me to draw that myself also, right? Okay, because students like, ma'am, please draw that, ma'am, so that we are able to understand that, ma'am, how you have drawn it. Okay, chalo. Now, this is C. Pi bond has shifted here and this pi bond has shifted here. The one where pi bond has shifted will be negative, and to from where the pi bond has shifted will be positive. Okay, this is how you make the resonating structures. Okay guys, got it? Got it everybody? Now, last is alternate double single bond. This is one of the example, only example will not focus because this I have taught in detail. Today we are doing the revision, right? So we will focus on the fast revision, right? Now back bonding. Third case is back bonding. Usually the students just see the alternate double single bond and p orbital and that thing. Nothing is clear in the head. So that's why we have back bonding. That is a part of resonance only, right? Okay, that is a part of resonance only. Now, see, for this you need to have two things in alternate position. One is electron deficient, other is electron rich. Electron deficient and electron rich both are in the alternate positions, right? Now, this carbocation is electron deficient and this lone pair is electron rich. So here back bonding will occur, and back bonding has the strongest priority, even stronger than inductive aromatic resonance. It is even stronger than the resonance itself, right? So here, that is why electrons will jump here, electrons will jump here, and here you will have the positive will shift to this side. Okay, reason being because here this was electron deficient. You have completed the electron deficiency by giving the electrons. Now nitrogen was supposed to make only 3 bonds. Here nitrogen is making 4 bonds. Now that is why nitrogen will have positive here. Electron deficient and electron rich pair you will have here. Right? Similarly here, electron deficient and electron rich pair. Electrons will be donated here. You will have pi bond here. Right? You will have pi bond here. And that is why this is going to, because oxygen is supposed to make only 2 bonds. Here oxygen is making 3 bonds. That is why it will have that positive here. Got it? So this is also a back bonding, right? Okay, chalo. I think that's it. Practice, so we will do in previous year questions only, right? Okay, chalo. This is a good question, so I'll take this question here. Now, if they ask you, this is a good question, okay? So that's why I'll take this question here, right? Oh God. I think Shubham has gone a little bit crazy. Chalo. Guys, are you able to see his chats or not? Let me know. Chalo. Okay, now back bonding, right? Here you have 3 things, okay? All of them has back bonding. This is negative, electron rich, electron deficient. See, the second period, the second element of all the p block groups will be electron deficient. So oxygen will not be electron deficient, but sulfur is electron deficient. Fluorine is not electron deficient, but chlorine is electron deficient. Can you tell me the reason? Because second element, if you talk about usse tepo, this sulfur will be having vacant d orbitals. Similarly, chlorine will have vacant d orbital. That is why I have picked up this question for you, that here they will ask you whether it will have resonance or not. Then you will say, yes ma'am, it will have the resonance. Ma'am, why it will have the resonance? Because this is electron rich and this is electron deficient. Sulfur is having vacant d orbital. Similarly, we know that boron is electron deficient. It can form only 6. BF3, if you talk about, it is having 6 electrons. So octet is not complete for boron. That is why boron is also electron deficient. That is why this is electron rich and electron deficient. Yes, back bonding will occur here. What about this one? Here the students usually say no, back bonding will not occur, because they feel that ma'am, chlorine has lone pair of electrons. How can you say that chlorine is electron deficient? Yes, chlorine has lone pair of electrons, but it also has vacant d orbitals where it can fill, it can occupy the electrons. That is why it is going to show the electron, it is going to show the back bonding. Is that thing clear to everybody? Is this thing clear to everybody? Related to back bonding question can be asked, and that is a very, very, very important topic. Right? Okay, guys, chalo. Now, let us see the stability of resonating structures. Okay, stability of resonating structure. Again, from here directly the questions are asked based on these four rules, and one question of your JEE is done, right? One question of JEE from these four rules, and trust me on that, this is a very simple topic, very simple topic. Very, just four rules, you just apply those rules, you will have the answer. Okay, chalo. Now, let us see these four rules. Okay, chalo. Now, the first here is sequence wise, you have to follow this. Okay, you have to follow this sequence wise. First, second, third, fourth. It's not like first you will see negative charge. No, first you have to see neutral, then you will see number of pi bonds, then you will see negative charge, then you will see charge separation. You have to follow this sequence only. Otherwise, you will get the answer wrong. Okay, now here. First thing is you will look for, they will ask you which of the following is most stable resonating structure, or they can ask you arrange the following in the order of the stability of the resonating structures. They will draw 2, 3, 4 diagrams there, and you have to predict the stability, right? How you will predict? First is neutral is always more stable as compared to charged. Okay, if you have any neutral resonating structure, that is more stable as compared to charge. It's positive, negative charge, whatever. Neutral is always more stable, right? Second, if you see, ma'am, all of them are charged only, ma'am, what to do now, ma'am? What to do now? Then look for the number of pi bonds. More the number of pi bonds, more is the stability. Okay? Third, ma'am, number of pi bonds are also same. Ma'am, now what to do? Now, if the number of pi bonds are also same, then look for the charge separation, right? Sorry, not charge separation. Look for the negative charge. Negative charge on more electron negative element, or you can just simply learn this thing. Negative charge more stable down the group along the period. It means if you have O negative and S negative, and this is F negative, right? If you talk about O negative and S negative, negative charge is more stable on S negative. If you talk about O negative and F negative, negative charge is more stable on F negative, right? So, when you are comparing these structures, down the group also negative charge stability is increasing. Along the period also, negative charge stability is increasing. That is the third rule. Fourth rule is, ma'am, here also I am not, first is, let me tell you one thing. Once you apply first, second and third rule, by the third rule, you will be able to answer it only. If they have asked you really complicated question, then you have to go to the fourth rule. That fourth rule is more charge separation. Charge separation means if you have C, this is positive, negative here, or if you have C, positive, negative here. Charge separation is more here. More is the charge separation, less is the stability. So here, this will be less stable and this will be more stable. This will be more stable. This will be more stable. This will be less stable. More is the charge separation. More is the distance between the charge. Less is the stability. Okay. Got it, everybody? Hanji. Everyone got it or not? Okay. This is the charge separation that I was teaching. That here charge separation is more. Here charge separation is less. Less is the charge separation. More is the stability. Now let us do the questions here, right? Practice here, okay? Out of A and B, which is more stable? Just we will go through the questions, and after that we'll start with the next thing, that is your hyperconjugation. Okay. If you see this thing here, we know that which is neutral. Ma'am, none of them is neutral. So first rule will not be applied here. Ma'am, both of them are having same number of pi bonds, ma'am. This is also one pi bond. This is also one pi bond. Second rule is also not applied here. Ma'am, but here you have negative on oxygen and here you have negative on sulfur. Oh, so we know that sulfur down the group O negative, S negative. Down the group negative charge stability will increase. So that is why S negative is more stable as compared to O negative. Answer will be A is less stable as compared to B. Okay, chalo. Next question. Which of the following is most stable? Right. Now, here also the same thing I am going to apply. Right. This is, firstly, I'll just check which of them is neutral. None of them is neutral. So, answer is not based on first. Second, I'll see which of them has more pi bonds. I know that this is having one pi bond, this is having two pi bond, this is having one pi bond. So, that is why answer will be B, based on the pi bonds. Right. Okay. Now, next is this one. Here, again you will see which of them. First rule is neutral and negative or positive. Neutral is always more stable as compared to negative or positive. Here we can see this is the neutral. So, this will be the most stable. So, answer will be A. Okay. Answer will be A. Okay. What about these four? What about these four? Okay. This is going to be the last question based on stability. Right. Okay. After that, we will do Chalo. This is going to be the last question on stability. Stability, if you see the stability here, stability is neutral. Firstly, we will see the neutral. We know that this is neutral, this is charged, this is charged, this is charged. So, neutral is having maximum stability. That is why A is having the maximum stability. Now, A is eliminated from this equation. Then we will look for the pi bonds. It is having no pi bond. It is also not having any pi bond. It is having one pi bond, not two. It is having one pi bond, right? So, one pi bond means this is more stable as compared to these. So, A, then you have B. Now, we have to decide between C and D. Hai na? Mostly they will ask you based on the stability throughout the structures, okay? This is C and this is D. Here, oxygen is having negative charge. Here, carbon is having negative charge. You have carbon, nitrogen, oxygen along the period. That means along the period, negative charge stability increases. That means negative charge is more stable on oxygen. That is why you will have C. After that, least stable will be D. Okay? 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 Okay, done? Chalo. Now, next is equivalent structures. Okay, equivalent structures. So, equivalent structures are having very high stability. Reason being, if you talk about these equivalent structure, as you can see, electrons will shift here, pi bond will shift here. You will have this structure which is same as this, also having two O negative and one double bond O. Right? If you shift the pi bond here, then this electron here, again you will have the same structure. Basically, these three structures are same only when you have the same structure. So, the charge, the equivalent charge will be minus 2 by 3. Can you tell me how? Minus 2 by 3 means you need to tell me the total charge on these species. The total charge is minus 1 and minus 1 means minus 2. And this charge is divided among 3 oxygens. Sometimes charge is here and here, sometimes it is here and here, sometimes it is here and here. That means among three oxygens, the charge is divided. So, minus 2 is divided among three oxygen atoms. So, it will be minus 2 by 3. Okay, it will be minus 2 by 3. Okay, yes, chalo. Got it? I don't know that how can people have so much time, yaar. I just wake up and then go and have my yoga class, and after that have my breakfast, then prepare for your classes, and then prepare for your PPTs. So many things. Prepare for the things that you need, your questions, your previous year questions, collecting those things. So many things I have. Now I don't have time to come and specially like write something on someone else's like life. I've never done that thing. Right? I'm so blessed to have good upbringing. Thank God. Chalo. Now, this is also equivalent structure only, right? Now, let us see the extended and cross conjugation. Extended and cross conjugation. See, extended conjugation is like, for example, you are going in one direction only. You are like, I want to crack JEE means, then I want to crack JEE advanced, then I want to get into IIT. After that, I'll get into Google. I'll have good package. I'll also, do this and that. That is your plan, right? That is your plan is sorted. You're going in one direction only. Now, some students, some people are like, okay, I'll also crack JEE. I'll also crack NEET. Okay, basically they are in two direction, diverted, cross, here on here. So what happens, most of the time what happens, that when you are preparing for both of the things, so what will happen, might be you won't be able to do even a single thing, right? So this is the thing here, right? That which is more stable, which is cross and which is. So now here a very beautiful, not beautiful diagram, a very funny diagram I have drawn here. For example, you are sitting on bike and your friend is driving, right? Now your both legs are on that bike only. Then to you are stable. You both are going in one direction only. Now, for example, you are sitting like, but here, this is one bike and this is other bike. And one leg is on this bike, one leg is on this bike. Will you fall or not? Tell me, guys. You will fall, right? You will fall. One leg on this bike, other leg on this bike, right? So what will happen? You will eventually fall here. The same thing happens with cross conjugation. Cross conjugation is less stable as compared to extended. Reason I'll tell you why. If you see what is cross and what is extended. Cross means this pi bond also can shift from this side. This can also shift from this side. Both the things can happen. But extended is like, firstly, this pi bond will shift here. Then this pi bond will shift here. This will be the extended conjugation. That is why we say that extended conjugation is more stable as compared to cross conjugation. Okay? Okay, guys? Chalo. Now, next is mesomeric and resonance effect. A simple trick I am going to give you on mesomeric and resonance effect. First thing is, what is mesomeric? What is resonance? Ma'am, what is the difference here? Right? The difference is, resonance is simple delocalization of pi electrons. But if you have some group attached here, because of that group, the electrons of benzene are either coming out of the ring or you are donating the electron into the ring. That is called mesomeric effect. So, mesomeric effect is resonance only. It is a sub part of resonance where some external group is involved here, right? So, if you talk about, there are two type of mesomeric. That's why in some books you will see plus M, some books you will see plus R. Both are same things only. But on benzene, you can't say there is mesomeric effect. On benzene, there is just resonance. There is no external group that is involved here, right? Okay, okay. Oh, I'm so happy, Satvik. Thank you so much, beta. Thank you so much. Thank you. You're also going to love GOC also. Once you go through this now, after that, you will see the question. You will see, ma'am, now that I'm able to solve, right? Now, simple. One is plus M, one is minus M. Simple thing I'll tell you here. Plus M is when the group that is attached next to the benzene ring, it is donating the electron, it is having the lone pairs. Simple trick is, when the group that is attached, this is a very, very important thing, okay? This will help you a lot in your organic chemistry. You will say, thank you, ma'am. This to have actually solved my so many questions, right? This group that is directly attached, that atom is, if it is having lone pairs, then it is going to show plus M effect. It is going to donate electrons to this ring. Okay? But if you have a group or atom that is attached to this benzene ring, but it is also double bondedly attached to another atom which is more electronegative, then this electronegative atom is going to take out the electrons here. It is going to take out the electrons here. That is why it will show minus M effect. Okay, that is why it is going to show minus M effect. Is that thing clear to everybody? Is that thing clear how it is going to show minus M? Examples I will show you now. Okay, this is the resonating structure I have drawn. I know that you already know how to draw the resonating structure because we have done all the chapters here, right? So this is the simple, this so you can easily make, right? Okay, this so you can easily make. This is not even a part of GOC. This is actually a part of other chapters. Okay, so electrons will jump here, electrons will jump here. Then these are the resonating structures that you will make. This so you can do this yourself or not. Do you want me to make this simple? है ना? Simple. Now, important thing here is the one which is having plus M effect. What you will observe on the ortho and para position. Ortho, para, ortho. You have the negative charge. That is the reason we say plus M effect is ortho para directing, right? Any electrophile, when it will attack on the ortho or the para positions because they want to find the electron density which is more on ortho and para positions, right? Okay. What about if you talk about all groups which show plus M are ortho para directing, okay? Now, next is minus M. Minus M, minus M, minus M. Minus M means when you have an atom that is having double bondedly attached to another atom which is more electronegative, it is going to show minus M effect. In minus M effect, you will observe that you have positive charge on ortho and para position. Because of this positive charge, electron density is more on the meta position. That is why minus M groups will show are meta directing groups towards electrophilic substitution. Electrophile, electron loving species, well, it will attack on that ring, it will attack on the meta positions. Okay, okay, chalo. Now, important thing, all groups showing minus M are meta directing towards this, right? This is the example. This is the example as you can see here, guys. Example, are you able to see, right? All the plus, you don't even need to cram, bacha. You don't need to cram this. There is nothing to cram here, I told you. The atom, if it is having the lone pair and it is not double bondedly directly attached to the more electronegative atom, that is why it is plus M. Ma'am, you will say, ma'am, here though you have double bond. Arey, I am not talking about any double bond. I am talking about that atom. That atom is not doubly bonded to any more electronegative atom. So that is why it is plus M effect. Here you will see all of them are doubly bondedly attached to some more electronegative atom. For example, this carbon is attached to oxygen with a double bond. This carbon also, it is C double bond O, OH. This is also double bondedly attached to oxygen. है ना? This I have drawn here. Sulfur is double bondedly attached to oxygen. SO3H, right? CO double bondedly attached. CO double bondedly attached. C triple bondedly or double bondedly is the same thing attached to carbon here, right? That is why this is also showing the minus M because it is sp hybridized, right? Okay, done. Chalo. Now, what about activating, deactivating? This is another concept where we will see halogen, right? Now, activating groups are donate electron density in the ring, withdraws electron density from the ring. Usually, when you are saying that it is having plus M effect, we will say that it is donating the electrons. Minus M effect means it is withdrawing the electrons. So, usually plus M effect is activating the ring and minus I is deactivating the ring. But there is one exception here. From this exception, again, the questions are asked. Okay, exception, like I am telling you all the highlighted. I know that you have very less time. I know that in that less time you want to do a lot of things. That is why questions we will do, we will also summarize everything. You can take this, then this is my last revision of GOC, ma'am. After this, I am not going to study GOC, ma'am. This is the last time, ma'am, I am studying the GOC. I am doing the revision of GOC before the exam. After that, I will only solve the questions, ma'am. This promise you have to make to yourself. Only then 100% concentration will be here. Only then this lecture will be beneficial if you promise to yourself, whatever ma'am is teaching, I'll learn it thoroughly and I don't need any other revision again and again. Just go through my notes after this and you are sorted. Okay. Now, generally mesomeric, then hyperconjugation, then inductive, that I will tell you. This also I'll tell you. Just ignore this part now. Generally, mesomeric is more as compared to inductive. Dominance is more. But in case of halogens, you have two things. Halogen is showing, because see, halogen is X, right? It is having lone pair, that is why it is showing plus M effect also. Because the halogen is having lone pair, when it is connected to the benzene ring, it is going to donate the electrons into the benzene ring. Okay, it is going to donate the electron into the benzene ring, plus M. It is also showing minus I. Can you tell me minus I? Why? Because, ma'am, halogen is electronegative, so it is showing minus I. Usually this same thing happens in case of phenol also. Same thing happens in case of phenol also. Phenol is also, this oxygen is showing minus I effect also and plus M effect also. But the difference here is that, in halogens we have the exception. In halogens, inductive effect is more dominating. This is the only case where inductive is more dominating, right? But this is oxygen is general case only. Here mesomeric is more dominating. That is why, guys, that is why we say activating and deactivating will depend upon the overall effect. Overall, it is deactivating group. So this question can also be asked to you directly, which of the following is correct, assertion, reasoning question, anything, right? But this is activating group. This is activating group. Can you know one thing from here? Both are ortho-para directing only, because this is also showing plus M, this is also showing plus M. Ortho-para or meta, that will depend only on the mesomeric effect. But whether it's activating or deactivating, that will depend on the overall thing. And overall is usually same as mesomeric only, but in halogen there is one exception, that inductive effect is more dominating. That is why deactivating group it is, right? Okay, got it? Yes. You will get the notes on Telegram channel, okay? You will get the notes on Telegram channel as well as the jungle box. There all the notes will be updated, okay? So all the notes will be updated there. Now, very good. Due to electrons of halogen, it has more minus. Due to electronegativity, very good. Now, halogens we have seen deactivating as it is plus M, so it is orthopara, but the rate of reaction will be less. Because that's why whenever you see there is some electrophilic attack on phenol, they can also ask you this thing directly. This is a question of GOC, not a question of phenol or alcohols. Students say, ma'am, this question was not there in ma'am alcohol. This question was also not there in ma'am haloalkanes, haloarenes. Beta, this is not a question of haloalkanes, haloarenes or alcohol. This is a question of GOC. They will ask you, there is a electrophile which is making ortho-para directing product, right? Which will be more reactive, phenol or chlorobenzene? Because phenol is activating group. It is going to increase because it is plus M effect is more. It is going to increase the electron density on ortho-para position to more extent. But here it is having less rate of reaction, because here it is a deactivating group, right? Okay, so rate of reaction is more in phenol as compared to chlorobenzene. Okay, chalo, this I have already shown here also, right? So this is activating group, right? And this is deactivating group. That is why rate of reaction is more here, right? Okay, chalo, this by mistake. Chalo, now next concept is hyperconjugation. So guys, hyperconjugation, simplest concept. Simple, simple, simple. Very simple concept. Very simple. Now the last two concepts are like simple. Aromaticity, directly questions are asked. Hyperconjugation, to itna simple it is, na. It is so simple, na. You will be like, ma'am, this is, so it's like a game, ma'am. Hai na? Chalo. Shall we start with this? Yes. Now, hyperconjugation effect. Right? Hyperconjugation, you just have to know 2-3 conditions here. Right? First is, it is also called no bond resonance. It is also called Anchimeric effect or Becker-Nathan effect. Okay? So these are the 3 names of hyperconjugation. Here, sigma electrons are delocalized. That is what is called no bond resonance. I'll tell you why it is called no bond resonance. If you see the resonating structures here, I'll just show you the resonating structures here. Wait a minute. If you see the resonating structures here, this, okay? That first is I need to tell you why it is called no bond resonance. It's not resonating structure, it's hyperconjugating structure. Here, this sigma bond will be shifted here. You will have the pi bond here, and this hydrogen is not having any bond with this carbon, but still it is connected. It is not an ion. Ion is having no bond. It is also having no bond, but it is sometimes having no bond, sometimes having bond. Right? So that is why it is called no bond resonance. The sigma electrons will shift here. It will be a double bond. This has become H positive. Right? So now no bond is there between carbon and hydrogen. That is why it is called no bond resonance. Right? Okay. Now we will see what are the conditions. Okay. So what is important for you in the exam? I'll just tell you that thing. Right. Okay. Yes. Chalo. Now 2 conditions beta we have. First is alpha carbon should be sp3 hybrid. Because questions are asked in your JEE means which of the following will show hyperconjugation. For that, so you don't just need to know these 2 conditions. As a free number it is. You just need to note these 2 conditions and your 1 question will be solved. 1 question is solved of your hyperconjugation. They don't ask you to draw the structures of hyperconjugation. That is why I'm focusing on the conditions here. Condition is alpha carbon should be sp3. Second condition is at least 1 alpha hydrogen should be there. Ma'am, what is this alpha carbon, ma'am? Whatever is the main thing, whatever is the focus point, this is my focus point, right? Here, this is not the focus point. Here, carbocation is the focus point. This is the focus point. This is sp2 hybridized. This carbon is also sp2 hybridized. So there is no hyperconjugation because this condition is not satisfied here, right? So alpha carbon is next to the main thing. The carbon that you will have is the alpha carbon. First condition is it should be sp3 hybridized. Second is it should have at least 1 alpha hydrogen, right? Okay, only then this is possible, right? What about this one? Again, no hyperconjugation. Reason, carbocation. This is alpha, this is alpha, this is alpha. Alpha is sp3 hybridized. I am agreeing on that. Alpha is sp3. This is also sp3. This is also sp3. This is also sp3. You are right on that thing. But it does not have any hydrogen. Alpha hydrogen is not present. So no hyperconjugation. Right? Okay. So simple questions are asked on this thing. Right? Okay. Next is, these are the 2 conditions and it should be a carbocation, a free radical or alkene. Hyperconjugation is shown in these 3 things: carbocation, alkenes and free radical. Okay, mostly you will see carbocation and alkenes only, right? Now, this structure beta, this is, so I have drawn this just for understanding. Right now for JEE means they will not ask you to draw these structures, so you can skip this part also, right? Our target is to get marks, right? Knowledge though we have taken like from past months also, you must have taken some knowledge. Right now our target is to gain the marks, right? So according to that I'll teach you. First thing is, here what they can ask you, this green highlight. For this green highlight only I have made this diagram here. But they will not ask you the diagram, they will ask you this point. Okay. Electrons are shifting from which place to which place? Sigma to empty p orbital. This carbocation is having empty p orbital. This sigma electrons are shifting to the empty p orbital. This you have to remember. In the hyperconjugation of carbocation, sigma electrons are shifting to empty p orbital of the carbocation. Right? Now, next is resonating structures. They will not ask you, but still just shift this here. This is no bond resonating structures will be formed. Right? Okay. Again, different resonating structure. Nothing too related here. What you need to remember is this thing. More the number of alpha hydrogen atoms, more is the stability. What if they ask you, write down the stability order based on the hyperconjugation, right? For that you need to know that how can you calculate the stability of the structures. So how you will calculate the stabilities? More the number, very simple, yaar. More the number of alpha hydrogen, more is the stability, right? So for example, these three things here. This is your alpha. The alpha is this thing. Wait a minute. This is alpha. If I just expand this structure here, these are my alphas. 3 alpha I have. 3 plus 3 plus 3. 3 hydrogen here, 3 hydrogen here, 3 hydrogen here. 3 plus 3 plus 3. It is having 9 alpha hydrogen. 9 alpha hydrogen it is having. Here to this carbocation, this is not the alpha. I am not saying alpha hydrogen is that is attached to the carbon. I am saying alpha hydrogen is which is attached to the alpha carbon. This is alpha carbon, this is alpha carbon. 1 hydrogen here, 1 hydrogen here, 2 alpha hydrogen. Which is more stable? A is more stable as compared to B. More is the alpha hydrogens, more is the stability. Right? More is the alpha hydrogen, more is the stability. Now let us do for free radical. Okay? Let us do for free radical, right? Again, they can ask you this thing. Alpha hydrogen, oh my God. Oh God. Can you hear some noises? Okay, so sorry. Okay, yes. Now, yeah, even I was scared. I just hope everything is fine. Okay, so, got little, okay. Chalo. Now, free radical, okay. So, free radical is same as carbocation only. Here they will ask you, where is the electron shifting? So, you can see the electron is shifting from sigma bond to the half filled p orbital, right? Sigma bond to the half filled p orbital, okay? Yes, sigma electrons to the half filled p orbital. This is the structure, you don't need to draw that, okay? This also we will do that, in the previous year questions only we will do. Chalo. Now, next is alkenes. Now, for alkenes, it's very, very important. That's why I was telling you that you should know all the things, because if they want to ask you intentionally, they will ask you for alkenes. Alkenes is, it is getting shifted from sigma, this sigma, to this pi bond, which is anti-bonding. Why I am specific? Because this very rare students know that this is anti-bonding. This the one who have actually read the concept only will know that this is anti-bonding or bonding. So this is, they will give you the option sigma to anti-bonding, sigma to bonding, or pi to pi. Answer will be sigma to anti-bonding. Okay, sigma to anti-bonding. Okay, sigma to anti-bonding, that is the correct answer here. Right? Okay, chalo. Now let us go through one question. Okay, I'll give you two questions which can be asked to you. Right? Okay. Because I am picking here very selected questions I am picking. Okay. I know the value of your time, so I'm picking very selected questions from here. Right? That I know that easy questions so you can do. You get stuck in difficult questions. Okay. And they will also ask you the tricky parts. Right? So here this is the simple question. Right? Here firstly you have to see how many alpha hydrogens. You will see that this is CH3, 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 it will have 12 alpha hydrogens. That means 12 hyperconjugating structure. 3, 3, 3, it will have 9 hyperconjugating structure, 6 hyperconjugating structure, no hyperconjugating structure. So answer will be A, B, C, D. This though you can easily understand. But this they will not ask you. The question, the problem is they will not ask you this thing in the exam. They will ask you this thing. They will ask you this question in the exam, where students will get stuck. Ma'am, this is also 6, ma'am. This is also 6, ma'am. This is also 6, ma'am. Ma'am, you were to telling more is the number of alpha hydrogen, more is the hyperconjugating structure. But here alpha hydrogens are only same. Then what to do, ma'am? Then what to do? Now, we will apply 2-3 concepts here. Very important to understand. Okay? Very important question. This is, mark it very, very important. Right? Now, first is 666, that means no alpha hydrogen concept is applied here. Right? Now, how to solve this? Firstly, though, this is also trans. This is not trans. Ma'am, why this is not trans, beta? We will study geometrical isomers tomorrow. Right? We will study that in the next class. Do you know the condition of geometrical isomerism? One students were telling me in my previous class, ma'am, both are trans, ma'am. How both are not trans? The one who is weak in isomerism. Next lecture we will study that in detail. Here I'll give you just one simple trick here. Geometrical isomerism means this is 1, this is 2, this is 3, this is 4. 1 should not be equal to 2, 3 should not be equal to 4. Only then GI can exist. And what is GI? Cis and trans is GI. Right? So here, this, both are not trans. Only this is trans, this is cis. This we will explain by some other concept. Right? This we will explain by some other concept here. Right? So basically, if you talk about cis and trans here, cis is more stable or trans is more stable. See, this is based on the repulsions. We know that in trans, there will be less repulsions. In cis, there will be more repulsions. That is why trans is more stable. Very good. Minhaj in the comment section. Very good. That trans is more stable as compared to cis. That means I can say that B is more stable as compared to C. But how they have said that A is more stable as compared to B? What is the reason behind that? That is the important point. Okay. How can you say B, like A you have answered on what basis? For that we need to draw the structures. Okay. For that we need to draw the structures. Now I'll just tell you how to draw the structures. So basically I have just drawn this in a simple way. This is C double bond C, C double bond C. Here you have one CH3, CH3 on one carbon, one CH3 here and one CH3 here. This is one CH3 and this is other CH3. I have just written the second CH3 in a expanded format. Right? Now this is my A structure. Let's make the hyperconjugating structure here. Sigma bond will shift here, sigma bond will shift here, right? And pi bond will shift here. This is the hyperconjugating structure. And this will be your hyperconjugating structure. Okay. What about this one? This is C double bond C, one CH3 on this side, one CH3 on this side. One CH3 on this side, one CH3 on this side. That means here and here. Now I need to see which is more stable. Again, I'll make the single bond. After the double bond, the second single bond will shift. After the double bond, the second single bond will shift here. The sigma bond will shift here. Pi electrons will come to this side. This will be negative here. Now, once you have drawn this side here, now what you will observe here, this is one negative and this is also that negative. Here you have CH3. Here directly to this negative, you don't have any CH3. Here, because of this CH3 here, there will be plus I effect. Electrons will be donated. So when you have a negative charge, electrons you are donating to that negative charge, then it will become unstable. That is why A is more stable as compared to B. Okay, A is more stable as compared to B. Now I have just answered this. The explanation I have given you. But for the exam though, you just remember this thing, that when you have this structure, this is more stable, then you have trans, then you have cis. If they ask you in the assertion reasoning, then you should answer that also, that because of the plus I effect in the hyperconjugating structure, that is making the hyperconjugating structure of trans unstable. Okay, reasons I am telling you the reason because of the assertion reasoning, right, or statement based questions. But otherwise, if they directly ask you the stability, then so you have to answer it directly. Okay. Okay. Then you have carbanion. So carbanion basically does not show any hyperconjugation, right? Carbanion will not show you any hyperconjugation. There is no hyperconjugation that you will observe in carbanion, right? But just like you have plus I minus I, just like you have plus M minus M, in the similar way you have plus H minus H. Okay, plus H minus H. Ma'am, what do you mean by minus H, ma'am? What do you mean by minus H, ma'am? Again, important question of your JEE. They can ask you which of the following it is showing. Students will be like, ma'am told carbanion does not show any hyperconjugation. But beta, this is the exception from where the questions are asked. Okay, so here it is showing the hyperconjugation, but that is minus H. All the other hyperconjugations were plus H. Minus plus H means here what we were doing. We were giving the electrons, donating. This was giving the electrons here, giving the electrons here, right? But in minus H, you have chlorine atom. Chlorine, Cl means clever. Chlorine is clever. Chlorine is electronegative. Chlorine is going to, right? It just look like cis, so little bit confusion. Very good, Minhaj. Because of that only, because it is looking like cis. So that's why students make minor mistakes there, right? So that's why I have picked up that question, because I know that students get confused in that question. Okay. So now chlorine. Chlorine means clever. It is going to take out the electrons. It is not going to donate the electrons. So what it will do, instead of donating its pi electron here, sigma electron here, it is taking out the sigma electron from this CCl bond. So electron is taken out by this one. You will have Cl negative here, and this pi electrons, right, it is taking out from this one. Right? That means it is showing minus H effect. What you need to understand, that when you have Cl3, C, CH2, right? Okay, this kind of situation, it is going to show you minus H effect. Okay, it is going to show you minus H effect. Okay, got it or not, everyone? Got it or not? Chalo. Now this was just practice question. Acha. Now electromeric effect, we are left with two effects here. Okay, electromeric effect. Application will be seen only in case of carbanion. Yes, only in case of carbanion. Only in case of carbanion, that too, That too when you have Cl, not when you have hydrogen. If you have any electron withdrawing, very strong electronegative effect, electronegative element there. Where so they have not asked you questions of minus H anywhere. They have not asked you that. But still, I have just told you this. What if they ask you this year? Hai na? So if they ask you, they will ask you a very simple question based on that. Okay? Yes. Acha. Guys, excellent work we have done today. Inductive, resonance, hyperconjugation. 3 effect we have completed in 2 hours. So firstly, so let's clap for ourselves, okay? Everybody, let's clap for ourselves because of you also. Because you guys are very dedicated today. I can see that dedication in the comment section, right? Because of you also, I am able to do this. Right? Otherwise, if I see students not interested, even I'll feel very low. How will be able to complete 3 concepts in 2 hours, right? With examples, with exceptions, everything, right? Let us do electromeric effect, very simple. Electromeric, and then we will do aromaticity, right? Okay, chalo. Now, electromeric effect, that is a temporary effect that will depend on the reagent. For example, you are that kind of student who will study only when someone outside will check on you. Are you studying? I am studying. Okay, okay, study. I'll go. Oh, ma'am has gone. Okay, chalo. I'll just keep the books somewhere else. I'll not study. I'll just scroll the reels. Right? That is temporary. Right? When you're dependent on the reagent, that is temporary. So here what will happen basically, for example, you have Cn negative, that is your reagent. This is the pi electrons. When reagent is coming, this pi electrons are feeling, oh my god, reagent. They are like very excited. Reagent. Now we will move here and there. In resonance, it was not happening like this. In hyperconjugation, it was not happening because of some outside reagent. But in electromeric, this is happening because of the outside reagent, and questions are asked based on plus E or minus E. Very simple question is asked based on this. Very simple. That when the reagent will come, electrons will shift to the atom. Electrons will shift, pi electrons will shift. This is called electromeric effect. Now, ma'am, what kind of question they can ask? The questions that they will ask you is based on plus E and minus E, the difference of these two things, plus E or minus E. Very simple concept here, very simple. You will laugh that, oh my god, ma'am, this is so simple. Now, when the reagent is coming and electrons are shifting to the same point where the reagent is attacking, right? Here we know that electrons are shifting here, right? And here the H positive, H positive is attacking on this side, right? H positive is attacking on this O negative. H positive is attacking on this O negative. That means this is plus E. So on that atom where the electrons are shifting, the reagent, the incoming electrophile or nucleophile, that is attacking on the same atom. So that is called plus E. Shifting of electrons and attacking of reagent on the same atom. Shifting of electrons and attacking of reagent on the same atom, that is called plus E. Now here you have some reagent that is Cn negative, let's say, right? Now, electrons, so we know that this is plus side, this is less electronegative, this is more electronegative. Electrons will be shifted to oxygen only. Electrons are shifted to oxygen, but Cn negative will attack on this positive. Because this is negative, this will attack on this positive. So this is called minus E effect. Got it? This is called minus E effect. When shifting and reagent attacking are on different atoms. Are on different atoms. Beta, tell me. Is that thing clear? Electromeric effect, right? Okay. Okay, Vijay, I'll take that. Okay, don't worry, I'll take that. After completing organic chemistry, I'll take that. Chalo. Now, next is aromaticity. Chalo, shabash beta, everybody ready for aromaticity. The last concept today. After that concept, we are going to take break and then we are going to start previous year questions. Okay? Then we are going to start previous year questions. Okay, beta? Chalo. Ready for aromaticity, guys? चलो हाँ जी aromaticity है ना yes don't worry that will be done aromaticity how many of you know Priyanka Chopra PCC do you know Priyanka Chopra bas will understand aromaticity with the help of Priyanka Chopra PCC okay Desi girl of India right PCC ma'am what PCC ma'am what PCC what Priyanka Chopra PCC is planar complete conjugation and cyclic first thing about aromaticity is PCC planar complete conjugation cyclic these three conditions it should follow right if these three conditions are followed only then it will be either aromatic or anti-aromatic right so now first thing here is either it will be PCC either there will be not PCC for example it is not planar it is not cyclic it is not having complete conjugation ma'am what is complete conjugation this is called complete conjugation double bond single bond double bond single bond double bond single bond that is called complete conjugation planar means that atom should be sp2 hybridized because sp2 hybridization what is the shape is trigonal planar so the second condition is the atoms should be sp2 hybridized okay atoms should be sp2 hybridized right chalo piece I that PCC nahi it's not pyridinium chlorochromate it's not pyridinium chlorochromate yaar it's I'm not doing oxidation here PCC is just a trick to remember planar complete conjugation cyclic okay chalo now if it is following PCC or either it will not be following PCC if it is following PCC then there are two things either aromatic or anti-aromatic if it is not following PCC then it is a non-aromatic beta after aromaticity we'll start with the questions okay this is the last concept right not PCC means it is non-aromatic if it is PCC is following either electrons will be 4n plus 2 pi or electrons will be 4n pi electrons. If there is 4n plus 2 pi electrons, it is aromatic in nature. If it is 4n pi electrons, it is anti-aromatic in nature. Okay. So now this is called Huckel's rule. And always remember, right? Always remember aromatic, then non-aromatic, then anti-aromatic. Okay. Right. Okay. Now, aromatic, non-aromatic, anti-aromatic. This is the stability order. And anti-aromatic are so less stable that nobody on this planet wants to be anti-aromatic. If you say anti-aromatic compound, it's unstable. Okay, it's very unstable. Now, complete conjugation is this. Now, beta, this is what we call as planarity. So, I'll show you a very simple concept of planarity. Always remember it should be delocalized. Always remember in planarity it should be sp2 hybridized. Okay. So the concept here is if you have localized SCH3, right? It is having 3 sigma bonds, so it is having sp2 hybridization only. If you have delocalized CH carbocation, then again what it will do? Again it will be sp2 hybridized. But if you have localized what? If you have localized CH3, this thing. If you have localized CH3 means which is not under resonance. Now, it is going to have 3 sigma and one negative charge. That means total 4. So, it will be sp3 hybridized, right? So, students also get, this question can also be asked to you, pure conceptual questions, right? That they can ask you that you have, why delocalized carbon ion is sp2? It should not be sp2. Reason, because if you draw it here, this is CH2, C, and this is negative. It is having 2, 3 sigma, 4 sigma. 3 sigma bond it is having, 1 negative charge it is having. That means total 4. That means it should be sp3 hybridized. Why it is not sp3 hybridized? Reason is, when you have delocalized carbon ion, it is not a pure double bond, right? It is sometimes single bond, sometimes double bond. That is the reason here this negative charge will not always be present here. Sometimes what will happen, electrons will shift here and you will have CH2 double bond C, CH2, and this will be negative here. In that case, here this will be 3 sigma. In that case, this will be sp2 hybridized. That is the reason this carbon is sp2 hybridized. This is a very conceptual question. Okay, right? Okay. So always remember, delocalized carbon ion is sp2 hybridized because it is involved in resonance. Okay. Chalo. Now, first aromatic compound is benzene. As you can see in benzene, what we have in benzene, PCC. Firstly, we will see PCC. Priyanka Chopra. PCC. Planarity, all of them are sp2 hybridized. They are cyclic. Complete conjugation, double bond, single bond. PCC is followed. Pi electrons, how many it is having? 1, 2, 3, 4, 5, 6. 6 pi electrons, so it is why it is aromatic in nature. First question done. Now guys, all these questions are your previous year JEE mains questions only. Okay, no doubt I will also show you how they ask you the question in the exam, but please go through these, right? It will really help you when you are solving the questions with me, right? Okay. Chalo. Now, beta, this is as PCC is followed because carbon ion, if it is carbocation, if it is in delocalization, it is sp2. PCC is followed. It is having 2 pi electrons because 1 pi here, 1 pi here, right? 2 pi electrons, right? Only pi electrons we calculate. It is having 2 pi electrons, and that is the reason. Guys, are you able to see me clearly? Is there any lagging here? Is there any lagging here? Is there any lagging or breaking of voice or something like that? Okay, chalo. Now, 2 electrons here. That is why it is aromatic. It is 4n plus 2 pi electrons. Here you have 1, 2 and 3, 4. Because negative charge, all the electrons that are involved in the delocalization are included in pi electrons. Very important line I am saying here. All the electrons that are involved in the delocalization are included in the pi electrons. So this is having 4 pi electrons. That means 4n pi electrons. That is why it is anti-aromatic, right? Next you have these 3 things. It is having PCC is followed. It is having 2 pi electrons. So it is aromatic. This is having 1, 2, 3, 4, 5, 6. 6 pi electrons. That is why 4n plus 2 pi electrons. That is why it is aromatic in nature. This is having 1, 2 and 3, 4. 4 pi electrons again. 4 pi electrons mean 4n pi electrons. That means this is anti-aromatic in nature. Okay? Right? Okay. Chalo. Now, next is this one here. First thing is, let us check the PCC. Planarity is followed, sp2, 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 sp2. Complete conjugation, cyclic, yes. Okay. Electrons, 1, 2. Electrons are 1, 2, 3, 4. 4 pi electrons, 4 n pi electrons, anti-aromatic. What about this one? PCC is followed. Carbon. Carbon here is involved in delocalization. Carbanion is involved in delocalization. 1, 2, 3, 4, 5, 6. 6 pi electrons, aromatic. Now students, tell me, is this thing clear to all of you or not? Is this thing clear to all of you or not? Now next is a very, very important concept that I am going to tell you here. Very important concept. Very important concept we are going to see here. That is this and this. From here to so many things you will learn, right? So here, what you will see, this lone pair on this nitrogen is involved in the delocalization, is involved in the resonance. The electrons will jump here. This will jump here. Then this will jump here. So, first thing is, I need to know whether it is PCC. Dekho, very important thing. I don't know if you ever thought about this or not. If I see this nitrogen, the hybridization, it is 1 sigma, 2 sigma, 3 sigma, and there is one lone pair that is involved. So it is 4. So it should be sp3 hybridized. That means planarity is not followed here. So you will say, ma'am, this is ma'am, this is non-aromatic. Have you ever thought like that? But I'll say this is planar only. So ma'am, why 4? So you just have told. The lone pairs that are involved in the delocalization are not involved while calculating the hybridization. So this lone pair is involved in the delocalization. So while calculating the hybridization, I will not even think about this lone pair. So this is 1, 2, 3. 3 sigma bonds, it is sp2 hybridized only. Right? It is sp2 hybridized only. So here, yes, it is planar. Complete conjugation, lone pair, single bond, double bond, single bond, double bond, single bond, lone pair. Yes, complete conjugation. Cyclic, yes. PCC is followed. Then you have how many electrons? How many electrons are involved here? These two electrons, and these two lone pairs are involved. So total 6 pi electrons are involved. That is why this is aromatic in nature. That is why this is aromatic in nature. Got it? That is why this is aromatic in nature. Acha, what about this one? Here, you have two lone pairs. Now, that is why this question is my favorite. My favorite. I'll tell you why. Two lone pairs. Students, usually they don't know how to calculate, ma'am. My basics are not clear, ma'am. Please clear them, ma'am. I don't know, ma'am. GOC is very tough. Arey, GOC is easy. Just remember this one thing that I'm telling you. The lone pairs that are involved in delocalization, only those are calculated while applying Huckel's rule, while calculating pi electrons. And the lone pairs that are not involved in delocalization are in the hybridization. So while calculating the hybridization of this oxygen, 1 sigma, 2 sigma, and this lone pair that is not involved in the delocalization, right? So here it will be 2 sigma plus lone pair, it is sp2 hybridized. Yes, it is planar. Ma'am, but what about the pi electrons? See, pi electrons are, you have 2 pi electrons here and a pi bond. Ma'am, 2 here, ma'am, 4, 5, 6, 7, 8, ma'am, 8 pi electrons anti-aromatic. Arey, nahi. 2 here, and only these electrons are involved in delocalization. These will shift here, this will shift here, this will shift here. Only those electrons that are involved are calculating in pi bond. So answer will be 2 plus 2 plus 2, that is 6 pi electrons. So it is aromatic in nature. Is that clear, everybody? Right? Okay. Chalo. Is that clear, everybody? 2 lone pairs, but delocalized is only 1. Very good, Satvik. Very good. Very good. Okay. That thing is clear. Once you are clear, once you are able to understand this point, I am telling you, you will get answer full marks in aromaticity. Full marks. I can guarantee you. Right? Because usually students get confused here only. Right? Chalo. Next is boron and nitrogen. Now, why I have taken boron here? Can you tell me? Students will say, ma'am, here though you don't have any lone pair, ma'am. Ma'am, no lone pair is present on boron. Ma'am, there is no complete conjugation. But do we know that boron is actually electron deficient species, right? So it has vacant orbitals. It is electron deficient. So that is why these will shift here. This will shift here, right? That is the reason it is having conjugation, right? So PCC planarity, because it is having 3 sigma bonds, so it is sp2 hybridized. PCC is followed here. Electrons are only 4. Why 4? Ma'am, 1, 2, 3, 4. On boron, ऐसा नहीं धक्के से ही मैम there are 2 lone pairs on boron. No, there are no lone pair on boron. It is electron deficient species. So 1, 2, 3, 4, it is anti-aromatic in nature. Got it? Chalo. This is so simple, right? This will be involved here 1, 2, 3, 4, 5, 6. So 6 pi electrons. So answer will be, this will be aromatic. Acha, this is important now. Here, this is important now. This thing is very important here, right? Beta, please firstly focus on JEE means, okay? Yes. Okay? Yes. Now, here, this you have the lone pair and here you have the lone pair. Now, students, understand one thing. This lone pair is involved in the delocalization. The lone pair, that is, see, I'll tell you one simple mantra, that nitrogen, which is sp3 hybridized, that lone pair is involved in delocalization. This nitrogen, which is sp2 hybridized, here the lone pair are not involved in the resonance, because this is double bond and on that only you have the lone pair. So how come these lone pair will be involved in the resonance? So lone pair is for double bond, single bond, lone pair. So this is not double bond, single bond, lone pair. This is double bond, single bond, lone pair. This is double bond, lone pair. So this is not a condition of resonance. That is why I have taught you resonance firstly, right? So it is double bond, single bond, lone pair, right? That is why lone pair are shifted here and this lone pair is involved in the delocalization. This lone pair is not involved in the delocalization. So while calculating pi electrons, you will have 1, 2, 3, 4 and these two, that means total 6 pi electrons and answer will be aromatic. Okay. Is it cross resonance? Yes, it is cross resonance in boron. Yes. Very good. Very good. Very good, Satvik. Very good, Minhaj. Shabash. Very good. Now, okay. Acha, this is simple trick I have told the students, that the one here you can see in pyridine, right? In pyridine here the lone pair are not involved in the resonance. So while calculating the pi electrons in the pyridine, you will calculate 1, 2, 3, 4, 5, 6 only the pi electrons, not the electrons of this lone pair of nitrogen, right? Because these lone pair are not involved in the resonance. Okay, got it? Yes, everybody. Now we are going to do anulenes, because from anulenes also they ask you question. That is a sub part of aromaticity. Okay, sub part of aromaticity, that is anulenes. Okay, beta. Chalo. Sub part of aromaticity, that is anulenes. Now, first you need to understand what are these anulenes. Anulenes are basically monocyclic. There will be only one cycle, right? Okay, monocyclic, complete conjugation, alternate double single bond. What I said? One cycle, alternate double single bond will be there and complete conjugation will be there. That is called anulene. Okay. Now, anulene, so I'll give you simple trick on anulene. Okay. In the end, I'll give you simple trick how to remember that. Right? So first is complete conjugation, monocyclic, that is called anulene. This number that is written in front of anulene, that represents the number of pi bonds, you can say. That represents the number of carbons. So if 4 is mentioned here, that means 4 electrons are present here. Number of pi electrons. This is represent number of carbon or number of pi electrons. Okay. This is 4, That means 4 pi electrons and 4 carbons you will have here, right? Okay. Now, this is PCC. PCC is followed, but it is anti-aromatic in nature because of 4 pi electrons. That is a case of anti-aromatic. What about this? This is 6-anulene, and 6-anulene is nothing but it is benzene only, right? So here we know that benzene is having 6-anulene, 6 pi electrons, which is 4n plus 2 pi. That is why it is aromatic in nature. Ma'am, then 8-anulene. Ma'am, why this 8-anulene? Very, very important. Your previous year question, okay? Very, very important. Directly this question is asked. Which is aromatic, which is anti-aromatic? Directly this question is asked, okay? Reason is 8-anulene. Now, 8-anulene, if you see this directly, you will feel that, ma'am, this is having 1, 2, 3, 4, 5, 6, 7, 8, ma'am. All of them are, ma'am, sp2 hybridized. There is complete conjugation, it is cyclic, ma'am. PCC is followed, ma'am, it is having 8 pi electrons, ma'am. It should be anti-aromatic, but that is wrong. It is non-aromatic in nature. Can you tell me the reason? The reason is the structure. Its structure is actually a tub-like structure. Okay, it is having a tub-like structure. That is why it is non-aromatic. It is not a planar compound. It is non-planar compound. PCC is not followed. That is the reason 8-anulene, mark it somewhere, 8-anulene is non-aromatic in nature. I'll just write down the things that are non-aromatic. First is 8-anulene is non-aromatic. Because see, seeing aromatic and anti-aromatic is not a big deal. Why? Because calculate the number of pi electrons, you will get to know. Just apply 4n plus pi, 4n plus 2 pi rule, you will get to know. Problem is with non-aromatic because you have not seen the structure yourself. You have to remember that 8-anulene is having tub-like structure. It is non-aromatic in nature. First thing. Second is 10-anulene. Again, it is non-aromatic in structure. Can you tell me why? Again, it is non-aromatic, non-planar. Reason is here, this is hydrogen, this is hydrogen. We know that it is supposed to make sp2. That means the angle should be 120 degree. This should be trigonal planar. The angle should be 120 degree, right? Okay. If you see the angle, it should be 120 degrees, something like this. Okay. Chalo, I don't have the structure now. Okay. Wait a minute. Chalo, I don't have the structure now. That means it should be in one plane. But exactly what will happen? Because of the angle strain, because of the repulsion, very good, because of the repulsion here, because of the repulsion between this hydrogen and hydrogen, what will happen? Actually, they were supposed to be like this. They were supposed to be in one plane. It is having a trigonal planar geometry. But what will happen because of this repulsion? This will go this way and this will go this way. It will move out of the plane, right? And because of this repulsion and this out of plane nature, it is exactly non-aromatic and non-planar. So write down 8-anulene because it is having tub-like structure, 10-anulene because of the angle strain, okay, or repulsions, right? Now, 12-anulene is also non-aromatic, again because of the repulsions of hydrogen, hydrogen, hydrogen. This is experimentally seen, okay, this is experimentally done, right? 10 is also having repulsion, 12 is also having repulsion, that is why it is non-aromatic, but in 14 there is no repulsion. So you can just write down 8, 10 and 12. They are non-aromatic. 8, 10 and 12 are non-aromatic. 8 because of tub-like structure, 10 and 12 because of the repulsions of the hydrogen it is having angle strain. Because of that, it is a non-planar structure. Others are simple only. Others are to 14. Mostly, to they will ask you either 8 or 10 or 12. They will ask you either, if they ask you question from anulenes, they will ask you either 8 or 10 or 12 if they want to confuse you. Right? Others are so simple. You can see that this is having 14 electrons, 14 carbons it is having. 14 electrons means this is in the category of 4n plus 2. If you put n as 3, 4, 3, 12 plus 2 is equals to 14. That means this is aromatic in nature. That means this is aromatic in nature. है ना? So this is your 16 anulene. 16 anulene again, 16 electrons. 16 electrons are in the category of 4n plus pi electrons. That means it is anti-aromatic. Here, so you just need to calculate the electrons. That is also mentioned here. This number is telling you the electrons. Okay. So just calculate the pi electrons. 18 anulene. How many electrons? 18 electrons. Again, this is falling into the category of 4n plus 2 pi. If you put n is equals to so if you put n is equals to 16, I think my throat will be gone. So if you put n is equals to 14, n is equals to 4. So it will be 4 into 4, 16 plus 2, 18 pi electrons. And here what you will see, this is aromatic in nature. Okay. So what we observed, anulenes 8, 10 and 12. They are non-aromatic. Others are either aromatic or anti-aromatic depending upon the pi electrons. Okay. Yes. Okay, beta. Noted. Ma'am, have you taken your dinner? No, yaar, I have not taken my dinner. I have not taken it yet, but you can take this along with the class. But yaar, I'm giving you the time. I'm giving you a break now. Now you can have your dinner. Chalo. Now, what we are going to see here, anulenes. This is the last part, last table that I have formed for you. If it is planar, how many anulenes are planar? 4, 6, 14, 16, 18. These are all your planar anulenes, okay? 4, 6, 14, 16, 18. These are your planar anulenes. Okay, do we need to remember their structure? No. You don't need to remember their structure. You just need, structure is simply just see whether it's monocyclic. It is monocyclic, na? It is monocyclic. Alternate double single bond it is having. Yes, 1, 2, 3, 4, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 9. 18. Right? So it is 18 anulene. And by this you can easily say that this is monocyclic alternate double single bond, and this will mention the number of carbon atoms that it is having. Okay. So they will also, if they ask you which of the following is 18 anulene, so you just have to calculate the number of carbon atoms. Okay. Acha, so Chaitanya, how's your experience then? Now, this is the last table that I have for you for anulene. Simple, yaar. In exam hall, you will not have that much time to draw the structure, this and that. You need to save your time in organic chemistry. Organic chemistry and inorganic chemistry is going to save your time. You need to spend your time in maths, spend your time in physics. In the exam, the numericals of physical chemistry, physics and maths, they are going to consume your time. So organic chemistry and inorganic chemistry, they are going to save your time in the exam. That's why these two things are very important for you. Take as many number as you can get from these two things, right? Okay, because they are not time consuming, right? So here just remember anulenes, planar. Planar are 4, 6, 14, 16, 18. This you don't have to remember. Just remember non-planar are 8, 10 and 12 are non-planar. 8 is having tub-like structure. 10 and 12 is hydrogen-hydrogen repulsion. That is why they are non-aromatic. Rest, it will depend on whether it is 4n plus 2 pi will be aromatic, 4n pi will be anti-aromatic. Okay, great. Okay, perfect. Chalo. Now a good question on this one. 2 questions more and then I'll give you the break. Right, then we will start directly with the previous year questions of your JEE. Right, directly with the questions. Then you will get the confidence that whatever ma'am has taught is there in the previous year question. Right, okay, chalo. Now, okay, let me take 2 minutes of let me breathe. So this is one structure they have drawn. They are saying that with HCN, which will react faster? This is what they are asking you, right? We know that with HCN, what will happen? This double bond will jump here and you will have the formation of this O negative and positive here. Here also this will jump here. You will have the formation of O negative and positive here. Now just focus on this thing. I know that this thing here is actually 1, 2, 3, 4, 4 pi electron. This is anti-aromatic. This thing here is 1, 2 electron. This is aromatic. So that reaction will happen, which is going to give you anti-aromatic product. The reaction which is going to give you anti-aromatic product will not occur, right? The reaction which is going to give you, I don't have here, water bottle is totally, like I have finished the water bottle here. So I'll go in the break and then again fill this bottle again. Chalo. With B, because it is forming aromatic ring here. That is why reaction will occur fast here, not here. Here. Okay. Now, next is here to beta, electron got shifted here because oxygen is more electronegative. Always this will not happen. For example, you have this kind of structure. Now this is carbon, this is hydrogen. Now the electrons will get shifted to the carbon because carbon is more electronegative. Electrons are getting shifted here, electrons are getting shifted here. Right? Now, this is negative, this is negative. Right? Now, we know that 1, 2, 3, 4, 5, 6, 6 pi electrons aromatic, 1, 2, 3, 4, 4 pi electrons anti-aromatic. So, this reaction will not occur. This reaction will take place. Okay? Got it? Got it, bachcho? Everybody? Any problem here? Any problem here? Any problem here? I'm so happy. But I was so tensed today. Why I was so tensed? I was like, I need to complete GOC. Right? GOC itself is a very time-consuming topic. Completing inductive, electromeric, mesomeric, resonance effect, hyperconjugation effect, Anulene's aromaticity. I was like, how will I do that? I was so tensed along with the previous year questions. I was so tensed today. Literally, I had my lunch at 5:30 p.m. because of this. I was like, oh my God, our class is about to start. Now I have to have my lunch. Because, this is, I know that what's the importance of your time. So I didn't want it ki, I'll just take the lecture for 7-8 hours. I was like, if I can complete this lecture, if I can complete GOC theory part in 2 to 3 hours, that would be great. Because I know that 1 hour it will take us to complete previous year questions then. Because concepts we have already learned. So I am so relaxed today. Today I will have a very good sleep. Right? So this is the passion that I have for teaching, that, okay, it doesn't matter. Nothing matters if I can save your time and also teach you good concepts in very less time. And if you can get benefit out of that. Now, beta, if you see this thing here, this is the structure, right? I am just exposing your mind to like more and more questions. If they ask you this kind of questions, right, then trust me on that, that is a good question, okay? Okay? Now, but it is also a simple question. Now, firstly, they can ask you, this is the compound. They can ask you, this is A thing, this is B, right? If the electrons got shifted here, that is A path. If the electrons got shifted here, that is B path. Which path it will follow? Same thing you are going to do. If this path they will follow, then here on this triangle, on this cyclopropene, you will have positive charge because electron has shifted from this side. And here you will have the negative charge. So here I have the negative charge, right? That is why this blue path I have drawn with blue. This pink path is when the electrons will shift on this side. So here I will have the negative and here I will have the positive. First, you tell me, is this thing clear to everybody? Is this thing clear to everybody? Right? We are almost done. Yes. Now, here, this is how many electrons is divided? 1, 2, 3, 4, 5, 6. 6 pi electrons, right? Aromatic. This is 1, 2. That means this is also aromatic. You have drawn 2 aromatic intermediates. You have drawn 2 aromatic intermediates, guys. So definitely this reaction will occur by A path, not B. Because in B path, you are having 1, 2, 3, 4, 4 pi electrons anti-aromatic. Again, 1, 2, 3, 4. 4 pi electrons again anti-aromatic. Why would it want to become anti-aromatic? Stability is aromatic, then non-aromatic, then you have anti-aromatic. No reaction will occur if the product is anti-aromatic. Okay? Got it? Welcome, beta. Welcome, JEE aspirant. What's your name? How can I say JEE aspirant, JEE aspirant? What's your name? Tell me your name in the comment section. I want to also know your names, yeah. So very good, very good, Shanmugham, Shanmugham, Ran and Sachin, JEE aspirants, Minhaj, Sridharan, Atharv, Anandu, Satvik. Very good. Chaitanya, very good. Chalo. So guys, that was about our theory part of GOC. Congratulations, we have done GOC. Right? We have completed all the electromeric effect. Right? Everything we have done. Right? I think rearrangement of carbocation, we will not do today. Right? That we will do in the next part. But yes, we are going to do previous year questions after the break. Okay? After that, I have previous year questions like this, okay, like this. These are the previous year questions that we are going to solve. Okay, these are the previous year questions. See, among the given compounds, the total number of aromatic compounds. So, all these previous year questions we are going to solve today itself. Okay, beta? Chalo. So, let's have the break. Let's have the break. Next questions, okay? So, let's take the break for 15 minutes. I'll give you the break. So, I'll see you at sharp 9 p.m. Okay? Yes, everybody, let's do previous year questions after this. Because that is where you can test your knowledge, and you never know, the same question directly will be asked in your JEE Mains 2025. Right? Okay, and yes, the previous year questions are repeated. Right? Okay? Okay, beta? Chalo. So, I'll see you at 9 p.m. Is that okay? Chalo. Now, you can also have that break in your head. Wait a minute. Wait a minute. Just give me a second. Just give me a second, guys. Okay. So, is this break time? Yeah. I'm about to start the break here. Okay. So, I was just looking for something, but my board is not working. This is break time only. You can go. I'm just checking that why this is not working. Because I don't want to. Because these notes are very important, na? So, I don't want to waste these notes. So, close window, save. Let's see if our notes are saved or not. Yes, they are. They should be. They'll just cry here only. It's a big file, na? So that's why. But at 9 p.m., I'll see you all at 9 p.m. Okay? Just give me a second. Yes. So I'm giving you the break here. It is at 9 p.m. Break, or you can say just resume session at 9 p.m. And here we are going to do the previous year questions of JEE Mains based on GUC. Based on GUC. This is what we are going to do after the break. Okay, so your 10 minutes break is going to start now. Right? Most welcome, beta. Most welcome. Thank you so much, Senti. Thank you so much, Seninthi. So I'll just give you the timer here. This is the timer, and your break starts now. Arey, hello. Arey, Om Mishra, don't spoil my hard work like that, yaar. I have not copied from anywhere, yaar. Don't spoil my hard work like that. It's a hard work of 3 4 years. Okay. So, yes. So now, guys, as you can see here, right? We all teachers, we study ourselves. We don't generate the questions, guys. We don't generate electromeric effect or resonance effect, right? We are all teachers. We study, right? Maybe we have studied from the same book. Like, ma'am, अरे यार, this much very sad allegation you're putting on me है. Chalo. Now, guys, welcome back. Maybe from the same reference, I don't know, right? So, okay, but these are mine only. Not mine, yeah, but I would say maybe from the same reference you can say, because we all teachers, we study from, like, there are some specific books, right? I to usually myself study from foreign authors, because when I was doing my MSc, so I was studying from that only. Maybe other teachers are also studying from that, right? Okay. Acha, Om Mishra, I'm so sorry. Right? I don't even know who this person is. So I'm so sorry about that. Acha, chalo. Now let us see this thing here. Acha. Now, where we have covered all the things. We have covered inductive, we have covered we have covered uh, inductive effect, aromatic effect, resonance effect, hyperconjugation effect, all the things we have covered now. Now, before landing to the previous year questions, firstly, if you want to see the previous year questions of past 2 years in detail, you want to cover all the session, you want to do those 1320 questions from all the 44 shifts, then guys, we have this booklet for you, where you will get JEE test series plus JEE means previous year book also, right? The link is in the description. If I let me show you the link here, just give me a second. Okay, just give me a second. Sure. If you can see this here, it is actually the third link. Okay, so JEE previous year books and free topic wise recorded lectures. JEE previous year books, free topic wise recorded lectures, focus means and JEE. Just click on this, right, and you will get to this portal where you can purchase this book here, right? Okay, so I think that is clear to all of you now. Now let us start with the lecture again, right? Okay, so let us start with the session. Let us start with the lecture. Ready for the previous year questions, guys? Ready for the previous year question? Yes. Varun Dhawan. Yeah, what comedy you guys are. Acha, chalo, theek hai. Let's see this thing here. Okay. Now, the set of meta. Now, I want to see answers from your side as well. Okay. I want to see your answers as well. Right. Okay. Very good. Now, first is the set of meta-directing functional groups from the following list. Meta-directing functional groups, right? What are the meta-directing? Meta-directing means the benzene ring should have that group which is double bondedly attached to a more electronegative element, right? Now here we can see NO2 is that group, definitely not NH2, so this is eliminated. Here NO2 is definitely that group, CHO is that group, SO3H, because SO3H is like this, S double bond O and this is H. CHO is like this, right? This is also applicable. NO2 is also applicable for NO2, right? NO2 is also applicable. Then you have COR. COR is also applicable here. So answer will be simple. Answer will be C is the correct answer. Isn't it simple? Right? Isn't it simple? So C is the correct answer. Right? Next question on your screen is, which of the following has highest boiling point? So more is the interactions, more is the force of attraction, more it is difficult to break that, right? So the more you are close, the more it is difficult to break that bonding. So here you have hydrocarbons, here you have alcohol, and here you have CHO, and here you have ether. Now, guys, hydrogen bonding is present in alcohol, right? Hydrogen bonding is present in alcohol. That is the reason alcohol will have maximum force of attraction, and that is the reason maximum highest boiling point. Very good. B is the correct answer here. B is the correct answer here. So answer will be B is the correct answer. Next question on your screen, we have the functional group that shows negative resonance. Beta, negative resonance means minus. Minus, again the same thing. Ma'am, we should have a benzene ring. On that benzene ring, ma'am, what we should have? A group which is double bondedly attached, or triple bondedly, you can say, attached to a group which is more electronegative. If you talk about NH2, it is not attached to anything. OH is not attached, double bondedly attached to any more electronegative element. It is showing plus M. It is also showing plus M. But this thing, C double bond O, OH, this is double bondedly attached to oxygen, which is more electronegative. So this is C part is your minus M effect. So answer will be C. Again, D is again your lone pair. So it is again showing plus M effect. So answer is C is the correct answer. Yes, very good. C is the correct answer, right? Okay. Now, these were the simple questions. Now, we have good questions, okay? Now, good questions. Which of the following has highly acidic hydrogen? Highly acidic hydrogen. That means acidic hydrogen means after losing that hydrogen, the carbanion that you will form will be very stable, right? Okay. So, here, if it has highly, which is what again, highly acidic hydrogen, right? So, usually methylene, this CH2, okay, chalo, if you want to see all of them, you can see that. If you replace CH2 here, if this will be replaced, it will be, if you replace hydrogen from this side, then it will have CH2 and this is one negative here, right? And this is not under any resonance, so this is not it's not stable because there is no resonance or anything. Here, after losing one hydrogen, it is having one resonance with this double bond. So here we can say that it is stable. So it is still in our list, right? Here, again, this is CH2. Again, negative it will become. Here also it is CH2. This is negative it will become. Both are good amount of stability because of resonance. Here, though, you don't have corresponding to this, you don't have any CH2 group here. That is why not that much stability. But can you see one thing here? This is your CH2. Here, if you talk about any other element, if you talk about this CH, it will become negative. If you talk about this CH, it will become negative. All of them will have one resonance. This also, this CH will have one resonance with this C double bond O, right? This CH2 will have one resonance with this CO. One resonance will be formed to everywhere. But if you talk about the D part, here the compound that you will have is C double bond O. If it loses hydrogen from here, so it will have the formation of CH negative. This is C double bond. This is CH2 and this is CH3. Now this CO is having two resonance. First is this one, second is this one. So basically two resonance it can show. That is why this is more stable. More the resonance, more is the stability. So answer will be D is the correct answer. Okay. D is the Hanji. Okay. So D will be the more stable. Now next is you have the ascending order of OH. They are asking the ascending order of OH acidity of the group in the following compounds. Firstly, though, what is this BuOH? Array, simple. This is nothing but this is CH3, CH2, CH2, CH2OH, right? Butyl, N-butyl they are talking about. Now they are saying that ascending order of OH acidity of the following group. Now guys, whenever we are going to talk about acidity, a simple concept you need to remember here, that is, if you're talking about an acid is one which is losing H positive, right? Now, for example, you are an acid. That means you will lose H positive. Now, you will only lose something if you are more stable after that. है ना? You will only do things which will make you stable. Why you want to prepare for JEE? Why you are so much dedicated? You are like sitting here doing the hard work at 9:15 p.m. where anybody, maybe some other person is out there chilling. You are studying. Reason, you know you will be stable after that. So, why will it lose H positive? If this carbon ion is stable, then this will be a good acid. That means whenever we want to check the acidity, lose H positive, and the thing that you will get is telling you your stability, right? So here it will be O negative, it will be O negative, here also it will be O negative, here also it will be O negative, here also it will be O negative, O negative. I told you one thing, if you talk about a carbon ion, when you are donating something, it is making it unstable. When you are taking something, because it is like a stress, it is making it happy. So it's like a stress. When you are donating electrons to this negative side, it will be unhappy, right? When you're taking out, it's like stress. When you're taking out stress for someone, they are happy, right? So here you need to see that electron donating and electron withdrawing group. So what you will see here, we have, okay, right? Okay, we have two NO2 group here, right? That means more is the electron withdrawing group, better, happy it will be. Someone is taking out electron, I am so happy. They are taking stress from me, I am so happy, so relaxed I am, right? So two friends, NO2 and NO2 are taking away the electrons. So this E is very happy, very acidic, very stable carbon ion is formed. So it is happy. So this is highly acidic in nature. So E will have the maximum. In all the cases you have E, right? In all the cases you have E. Now we will see the next thing. Whether it's B or A. Now from the options only you can see that 3 times they have done B. That means B must be the right answer. But still we will see that, right? B or A. After this, E is the maximum stability. After this, can you see any electron withdrawing group? Yes. Here I can see the electron withdrawing group. That means here you have 2, here you have 1, but it is electron withdrawing. It is taking out electron here. So when you are taking out electron, right? When you are taking out electron, that is called, beta, one more thing I'll tell you. One more thing, that at meta position, mesomeric effect is not applied, okay? At meta position, mesomeric effect is not applied. So here it is showing minus I effect, but at para position, it is showing minus I and minus M effect, okay? These are important things, right? Here it is showing minus M and minus I effect. At meta position, mesomeric effect is not applied, okay? That is why here I have written only minus I, right? Now, it is more electron withdrawing because here you have extra minus I, here you have only 2 minus I. So this is, after E, you will have B, right? Now, after this is B, this is C, this is D, okay? This is B. Now, after this, I have donating, this is also donating. Here you have no effect. So after this, I will have D. After this, I will have D. So this is EBD, EBD, EBC. So these two are eliminated from here. Next, I want to see whether it's C or A. From there, I can get my answer. I know that here you have oxygen, right? Here you have oxygen which has lone pair. So it is going to donate the electrons here, right? It is going to donate the electron to this benzene ring. Then the electrons will be given here. It is donating the electron by plus M effect. It is donating the electron by plus I effect, beta, which is more stable. Always remember this very important thing I am writing here. Very, very important thing, beta. Barhi. Okay, remember this thing. Okay, where should I write? Just remember this thing, that is Barhi. Now, can you tell me what is this Barhi? So, there is a movie of Ranbir Kapoor, that is Barfi. Okay. So, in the same way, we have Barhi. Barhi. Have you ever eaten Barfi? Barfi in Diwali season, you must have eaten Barfi, Barfi, Barfi. So, similarly, we have Barhi. Barhi. Can you tell me what is this Barhi? Firstly, back bonding, then aromaticity, then resonance, then hyperconjugation, then inductive effect. This is Barhi. So from here we can see that resonance or mesomeric effect is more stable as compared to inductive. Right? Okay. This is the order of stability. Back bonding, aromaticity, resonance, hyperconjugation, inductive. Okay. Yes. Now by okay Satvik. Okay. Chalo. Now here you have D or this. We know that this is having more donating effect as compared to that. So this is making it even unstable. So C is unstable as compared to A. Reason being A is showing less donation. Less stress A is giving. This is giving more stress. C is giving more stress. A is giving less stress. So the one which is giving less stress, both are giving stress. But this is giving less stress, so that is why A will be more stable as compared to C. So this is the order. So answer will be B is the correct answer. Okay, B is the correct answer. Very good. Oi, hoi, this is ortho position. I'm so sorry. This is ortho position only. This is ortho position only. I'm so sorry. I don't know how I missed that. Chalo. Now, wait a minute. Why it is written A than this? AC. AC. C is more stable. This is giving you plus M. This is giving you minus I also. Acha. Okay. Okay. So sorry. So here it is not only giving us plus M, it is also giving us minus I. I forgot to write minus I also. Right? So it is also giving us minus I and plus M. It is only giving us donating effect. It is also giving us minus effect. Okay, so the overall thing we have to observe. Right, so here it will change. Right, so here it will be, because it is giving us minus I because oxygen is electronegative. This is giving us plus M effect because oxygen is plus M effect. It is like electron donating by resonance or mesomeric. So what will happen in this case, because of these two effects here, because this is also at para position, so this effect will be applied. So because of this effect, this plus I effect will be more as compared to this minus I and plus M. Because this minus I and this plus M, overall what it will do as compared to this plus, here you don't have anything which is taking out electron. Here you have one thing which is taking out electron. Okay, understood? So C will be more stable as compared to this, right? Okay, C will be more because here still you have minus I effect which is taking out electron. Okay, got it? Chalo. So answer will be not B, the answer will be D is the correct answer. Okay, that is an important question. Chalo. Now, next is very simple. Okay, here to very simple question. Cyclohexene is a type of organic compound. What type of organic compound it is? So it is basically a type of alicyclic, right? Alicyclic organic compounds. Very simple. Okay. Chalo. Next is nothing like GOC was there, so that is why I skipped that question. Now, next is among the given organic compounds, the total number of aromatic compounds that you will have. Okay. You have to tell me how many of these will be aromatic in nature. The total number of aromatic compounds that it will have. Okay. So if we talk about the aromatic compounds here, if I see this is basically double bond. PCC I have to see. PCC and total number of electrons. So firstly I will see the PCC. Okay. double bond, single bond, double bond, single bond, single bond. So it is not following PCC, so it is not showing any planarity, so it is not aromatic. What about this one? Here, double bond, single bond, double bond, single bond, double bond, single bond, and this ring is cyclic. That means this ring is aromatic in nature because it is having 6 pi electrons also. So this is aromatic in nature. And you will say, ma'am, but here to ma'am single bond, single bond. That is out of that ring. Now there are 2 rings. This ring is non-aromatic, this is aromatic. Right? So overall effect will be aromatic. One is aromatic, one is non-aromatic. So overall effect will be aromatic. Right? So overall this compound will be aromatic in nature. What about this compound? Lone pair, single bond, double bond, single bond, double bond, lone pair. That means this ring is showing you the aromaticity. Here, though, overall the ring is aromatic. Double bond, single bond, double bond, single bond, double bond, single bond, double bond. Right? So here, overall it is aromatic. So this is also aromatic in nature. Here, this thing is aromatic. This is also aromatic. What about this one? Double bond, single bond, negative, single bond, double bond, single bond. Again, all of them are aromatic. So this is also aromatic. So 3 compounds are aromatic in nature. Okay. 3, that is B, C and D are aromatic in nature. Okay. Chalo. Now, next is the order of relative stabilities of contributing structures. So this is what I told you about resonating structure, and how directly based on the stability they will ask you the questions. So now this is choose the correct answer from the options. So here it is. First you have to choose between neutral and charged. Which is neutral? This is the neutral. This is the neutral. So first will be the maximum stable. After that you have to see the pi bonds. Here also you have 1 pi bond. Here also you have 1 pi bond. So depending upon pi bond, so I can't answer this. Then I have negative charge. Here negative charge is on oxygen atom. Here negative charge is on carbon atom. Carbon atom, then you have nitrogen, then you have oxygen. Along the period, negative charge is more stable. That means negative charge is more stable on oxygen atom. So here it will be this one. So second will be more stable. After that you will have the third. So 1, 2, 3. Right? So the answer will be first is the correct answer. A is the correct answer. Okay? A is the correct answer. Next you have the difference in the energy. Now they are saying the difference in the energy between the actual structure and the lowest energy resonance structure for the given compound is. Actual structure and the resonance that means the resonance hybrid and the actual resonating structures. The difference is given by resonance energy. So very simple question it is. Okay, resonance energy. See, simple question they also ask you in JEE. Okay, okay, okay. Chalo. Now next is Davis, you can do, Roshan, you can do one thing. Whatever your query is now, you can just put that in the comment section. Okay, so whatever you want me to make video on, just put that in the comment section that ma'am, this is the thing that I'm getting stuck in, either for your JEE means 2025, 2026 or your advanced, whatever is your problem, you can put it there so that I can come up with a solution, right? Okay, yes. Now, the interaction between pi bond and lone pair of electrons present on the adjacent atom is pi bond and lone pair of the electrons. That means pi bond and the lone pair. This is what? This is nothing but this is resonance, right? Okay, simple. Next is, this is a good question. The ascending acidity, now they are saying that the ascending acidity order of following H atoms is. Ascending acidity, okay. So here it is H. That means after losing H, what it will become? This is CH, triple bond C, it will become C negative, right? Because H positive will be lost now. So this will be CH2, this is double bond, this is CH negative, this is C, CH3, this is CH3, this is CH3, it is a negative here, and this is CH3, wait a minute, this is CH3, this is CH2, wait a minute, this is CH3, CH2 and this is a negative here, right? This is what you are going to get, right? Okay, chal. Now, you need to tell me which of the carbocation is most unstable here. See, it is having 3 plus I. Firstly, so let me tell you which is sp and which is sp2. This is your, if you say this is having sp on, this is basically your sp carbon. This is sp2 carbon. This is sp3 carbon, right? So these two are sp3 only, so there is no issue in that. So out of this and this, we know that they are electronegative. We know that electronegativity is like this: sp, then you have sp2, then you have sp3. That means A will have the maximum electronegativity, right? So it will pull out the electron. So when you are taking out the stress, they are becoming happy. So A is having the maximum stability, this one and this one. Then you have the B. And that means B and C are already eliminated here, right? Because A is more stable as compared to B, because this is sp and this is sp2, right? This is so sorted. This is sorted. What about C and D? After that, should it be CD or it should be DC? Okay. Now here we know that 3 electrons from 3 sides alkyl groups are donating. Here from one side it is donating. So that is why from 3 sides it means it is very unstable. It is still okay. It is still okay. It is like I am getting donation, I am getting stress from 3 sides. Arey, JEE mains also, boards also, JEE advanced also. JEE means JEE most, JEE means JEE advanced and boards, right? 3 stress. So that's why your halat is like this, na? So here it will be unstable or stable, right? So this is your C, that will be least stable. So answer will be A. Okay? Yes. Very good. Option A is the correct answer. Okay? Chalo. Next is match the list. So you have to match the list here. Okay. Chalo. First thing though, you need to, firstly I want to see the acidic order. Firstly though, I just want to see the acidic order here. pKa value is inversely proportional, right, to Ka. That means the acidity. That means the acidity. So firstly though, I need to just write down the acidic order. Acidic order. Ethanol is basically CH3, CH2OH. Phenol is OH. Metanitro. Metanitro means something like this. Metanitro means on the meta position. Ortho and meta is over here. And this is para. Para is basically like this. Should I draw it or not? So I'm just drawing it like this. This is OH. Meta means NO2 here. And para is this thing. Okay? NO2 here. I'll just draw it here. NO2 here. I told you one thing, that at meta only minus effect, one minus effect is applied, right? So here only minus I effect is there. Here you have minus I and minus M, both the effect. So if I want to check the acidity firstly, if you talk about the phenol, okay? If you talk about the phenol and ethanol, ethanol will have the least acidity here, right? Ethanol is going to have the least acidity because that is aliphatic. There is no resonance. Here you have resonance, here you have resonance, here you have resonance. That is why ethanol is least acidic. So ethanol will be minimum. Ethanol will be minimum, right? Then ethanol we have done. After this we have phenol. Now phenol is like having the maximum acidity here, right? Reason being, because here you have minus I. Wait a minute, it will not have the maximum. Because here you have the negative. When from negative you are taking out the electrons, it is making it more stable. So after this, after A, you will have B. Okay? Because there is no effect. There is no plus minus effect here. But if you see on these, from these to ethanol is less, because here you have resonance, here you don't have resonance. Now between these three, phenol will be least acidic because it does not have any electron withdrawing groups. Here it has 2 electron withdrawing group, but here, even though it is far away, but it is having 2 minus effect. So that is why it will be more stable. So D will be more stable, D will be maximum. Then you will have C here. So answer will be A, B, C, D. So answer will be here A, okay. pKa value will be, wait a minute, A, then you have B, then you have C, then you have D. Now you have to take that A is having the maximum value of pKa, that is A is 2, A is 2, A is 2, A is 2, this one. B is having, D is having the minimum, D is having the minimum value, that means D is 3. Okay, so I think answer should be D. Yes, answer is D. Okay, got it? Got it, guys? Okay, beta. What is the value of meaning of pK? pK is actually, beta, like we have pH now. So pK is equals to minus log of Ka, right? That is an ionic equilibrium. But you just need to remember for organic chemistry that they are inversely proportional. Okay. Now, next is, which of the following molecule species is most stable? Most stable. Which of the following is most stable? Right? Okay. Now tell me which of the following is most stable based on aromaticity. You can see that it is non-aromatic, so it will not be most stable. It is having 1, 2, 3, 4. It is anti-aromatic, so it is also not most stable. This is non-aromatic. This is 1, 2, that is 4n plus 2 pi electrons. So this is most stable. It is aromatic. If you talk about this one, 1, 2, 3, 4, again it is anti-aromatic. So answer is A is the correct answer, right? A is the correct answer. Aromatic you have to search here, right? Okay. Acha, next question is example of vicinal halide. Vicinal halide is double bond. On that only you should have X. On the double bond only you should have X. This is not vicinal, this is aryl. Okay. On the double bond you should have X. On the double bond you are having X here. Right. So answer is A is your, sorry, vicinal I am saying A is your vinylic halide. By mistake. Vicinal is when two edges an atom have the same group. Okay. Like X. So here vinylic halide is A. Right. Okay. And what is allylic? Allylic is when you have double bond, then you have one carbon, then to that you have X. That means this is your allylic. This is your allylic. Okay. This is your aryl. This is your aryl. Okay. Chalo. Next question is the correct stability. Now they are saying the correct stability order of carbocation. Right. From carbocation, more is the donation, more is the stability. Because someone is having very poor. So if you give them money, they will be happy only, no? They will be sad, happy, right? So here, this is having 3 plus I. But then you have one primary, then you have secondary. So this will not be the answer. This definitely will not be the answer because 3 plus I means this will be maximum stability. Here also this will not be the answer, right? Okay. Because here you have CH3. This should be 3. CH3, C, hai na? ठीक है. C, it should be 3 here, right? Because then to the carbon atom is, we need to fulfill the tetravalency of carbon. Na? So here it is 3 degree, then it is 2 degree, then 1 degree, then you have methyl cation. So answer is C is the correct answer, right? Okay. More the plus I, more is the stability. A species having carbon with sextet of electrons and can act as electrophile. 6 electron it will have and it is going to act like an electrophile. That is a carbocation which has 6 electrons and it is attracted towards more electron density. So answer is carbocation. How many questions? Yes, a lot of questions. Right. Next is this question on your screen. Right. This is from your electromeric effect. Right. Okay. Now this is temporary effect. plus C minus C plus R minus R. 4 effects here. So see, first thing is here electrons are getting donated. Electrons are getting donated. That means this is plus M, right? Or you can say plus R, because here they have written plus R, so I'll write plus R only. Here I know this is NO2 group, electron are withdrawing from it, so this is minus R, right? Here electron is getting jumped to this position, and the hydrogen is also attached to this position. So this is plus C. Here electrons are getting attached to this position, but reagent is getting attached here. So that is minus C. So answer will be A is plus R, A is 4, A is 4, A is 4, A is 4, A is 4 only in first case. So answer is first. Okay, answer is A. A is 4 only in one case. Then B is 3, B is 3 plus C is what? 3. Yes. Okay. Then C is 1, C is minus C 1. Yes. D is 2, D is 2 minus R. Yes. Okay. So answer is A is the correct answer. Okay. Now, which of the following among is incorrect statement? Electromeric effect dominates over inductive effect. Okay. The electromeric effect is temporary effect. Hydrogen ion shows negative electromeric effect. The oxygen, the organic compound, shows electromeric effect in the presence of reagent only. So see, very important. That's what I was telling you, that electromeric effect are also asked. Okay, don't ignore that effect. Electromeric effect dominates over inductive. That is true. Electromeric effect is going to dominate over inductive. Reason is, in inductive only pi sigma electrons are getting shifted. Here pi electrons are getting shifted. Okay, you can break the bond, right, when you have some new reagent, right? So it is dominating. Electromeric effect is temporary. That is also true. The organic compound shows electromeric effect in the presence of reagent only. That is also true. We need reagent, right? But this thing, hydrogen ion shows negative. If you see this here, this was the hydrogen ion. Always, because hydrogen H positive, that is positive, it will look for electron density. Where the electron density will shift, it will also attack on the same side. So hydrogen will always show plus E effect, not minus E. So this is the wrong statement. So answer is third is the correct answer, because this is the wrong statement. Okay, got it? Chalo. Next is correct order. Now they are saying the correct order of stability of carbanion. The correct order of stability of carbanion, right? Okay, again based on arom. If you see these kind of structure, na, directly that should click in your head, because they are talking about aromaticity, right? Now this is having how many electrons? This is not even, this is non-aromatic. It is not even following PCC. It is also non-aromatic, right? This is having 4 pi electrons. This is having 6 pi electrons. So D will be maximum stable, because this is aromatic. This is anti-aromatic. This will be least stable. D will be maximum. So 4 and second are eliminated. A will be minimum. A is minimum here. So answer is third is the correct answer. Okay, third is the correct answer. Okay, got it? Yes, everybody? Understood? Wait a minute. D is maximum stable. A is least stable, because it is 4n plus. A is least stable. Okay, so this is going to be the final answer. Okay, 3, right? 3 is the correct answer. Okay, next question is, for the compounds, the increasing order of boiling point is, choose the correct answer here, right? So yaar, firstly, so what you see here, you have OH. Wherever you have OH, this is going to be the maximum boiling point. So D is going to be the maximum. So first and fourth are directly eliminated. Okay, first and fourth are directly eliminated. After that, it will be C, because both of the options, it is C only. And C is what? C is your aldehydic, right? We know that after alcohol, because it has hydrogen bonding. This has electronegativity strong, and this has pi bond. That is why This is having loose pi bond, that is why it is having slightly more forces as compared to ether. After this you will have ether. After this you will have ether. Ether is A, है ना? Ether is A. After this you will have ether. Then you will have hydrocarbon. Hydrocarbon is having very weak van der Waals forces. So answer is least boiling point is for B, then A, then C, then D. So answer is B is the correct answer. Very good. Okay. Next is number of carbocations from the following that are not stabilized by hyperconjugation is. That are not audible. Hello. Beta, I am to completely audible. Hello. Yes, it's audible. Okay. Now from here, you need to tell me number of carbocation from the following that are not stabilized by hyperconjugation. Hyperconjugation is alpha carbon should have sp3 hybridization. Alpha hydrogen should be there, right? So here if you see, alpha is not sp2, so this is not showing. So this is the first that is not showing any hyperconjugation, right? If you talk about this, here it is 1, 2, 3, right? It is also having CH3 here. It is having CH3. This Dundee, this one line means this is CH3. So it is having no hydrogen, no alpha hydrogen. So it is also not showing any hyperconjugation. Here you don't have any alpha atom or alpha carbon only. So this is also not showing any hyperconjugation. 3 you have till now. Here also this is not showing because this is CH3, this is CH3, this is CH3, right? So all of them are, it is having, wait a minute, alpha is sp3, this is alpha. This alpha is basically sp3 and this is having 3 alpha hydrogen. So it will show, this will to show alpha, this will show. This does not have alpha, so it will not show. 4, okay. So this is also CH3, this is CH3, है so alpha is having, so this is also show hyperconjugation because alpha carbon is sp3 and it is having alpha hydrogen. Achha, what about this one? Here it is having CH3, it is having CH3, it is having CH2, it is having CH3, है so this is the alpha that you have. Here this is the alpha, this is the alpha, this is the alpha, right? So all of them are showing, this is 3, 4, 5, 6, 7, 8 hyperconjugating structure. Here it will show 1, 2, 3, 4, 5, 6 hyperconjugating structure. Oh, I'm so sorry. Here you have tert butyl, beta. This is a different compound. This is not this compound. This is C positive and here you have C tert butyl group here. This is CH3, CH3, CH3. On this side also you have tert butyl group. CH3, CH3, CH3. Right? So here, this is the alpha, this is the alpha. Now here alpha is not having, here the alpha is not having any hydrogen. So this will also not show. So total it will be this and this. 2 are showing your hyperconjugation. They are asking you not showing hyperconjugation. 1, 2, 3, 4, 5. Total 5 are not showing the hyperconjugation. Okay? Okay? Chalo. Now answer will be 5 is the correct answer. Okay? Chalo. Next is which of the following are aromatic in nature? Aromatic in nature. Which of the following is aromatic in nature, beta? Which of the following? So this is basically aromatic, hai na? First you need to see aromatic. So definitely this is aromatic, right? Because one ring is aromatic. Double bond, single bond, single bond. Here also double bond, single bond, single bond, single bond, single bond. Right? If you talk about this double bond, single bond, single bond, not even a cycle, not even one ring is having aromatic ring. So this is not aromatic. Double bond, single bond, double bond, single bond, double bond, single bond, double bond, single bond, double bond, single bond. Okay, so this is your having, this is, wait a minute, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 anulene. 10 anulene is non-aromatic in nature. So it is non-aromatic, right? This is aromatic. What about this one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 means it is having 4n pi plus 2. If you put n as 3, then it will be 12 plus 2, that is 14. So it is 4n pi plus 2, so this is also aromatic. So answer will be B and D. That is, second is the correct answer. B and D is the correct answer. Okay? Very good, very good. Minhat, C will have the repulsion, steric hindrance it will have. That is why it is non-aromatic in nature. Okay. Next question is, the correct sequence of acidic strength of the following aliphatic acids in their decreasing order is, right? What they are saying? 14 anulene is aromatic. Yes. Okay. The correct sequence of acidic strength of aliphatic acids in this particular thing is, okay. So acids means a negative, negative, negative. Okay. First, I'll have to look at each option. Okay. Carbanion we will form. More is the electron donation, more is the stability, less is the stability. It is inversely proportional to the electron donating effect. Because to a carbanion, when you donate the electron, it becomes unstable. Okay. So here you have all the alkyl rings. When you are giving more electrons, it is becoming more unstable. So that is the wrong option. Here it is very weird, CH3, CH3, CH2. There is no sequence here. So this is not possible. Here, I think this is the correct answer because here you have 3 carbon chain, 2 carbon chain, 1 carbon chain. It has maximum plus I, so maximum instability. 2 less than that means more stable. Even less plus I donation, more stable. It has no plus I, so it will be having maximum stability. Answer will be C. Okay, answer will be C. Total number of aromatic compounds among the following compounds is, total number of aromatic compounds. Okay, you have to check the aromatic compounds. Yeah, this is definitely not aromatic. Double bond, single bond, double bond, single bond, single bond. No complete conjugation, not aromatic. Right? This is aromatic. Double bond, single bond, double bond, single bond, double bond, single bond. Aromatic. Double bond, single bond, double bond, single bond, double bond, single bond, double bond, single bond. But 1, 2, 3, 4, 5, 6, 7, 8. Tell me, beta, 8 anulene. It is aromatic or non-aromatic or anti-aromatic? It is non-aromatic because it is having tub-like structure. It is non-aromatic. It is also non-aromatic. This is aromatic. What about this one? 1, 2, 3, 4. 4 pi electrons, it is aromatic. Sorry, anti-aromatic. Anti-aromatic, that is also not aromatic. What about this one? 1, 2, 3, 4. There is no conjugation only here. So it is non-aromatic. Right? What about this one here? What about the first one? Is it aromatic or anti-aromatic? There is no conjugation. Double bond, single bond, double bond. No conjugation in a cycle, in a ring. Again, non-aromatic. So only one is aromatic. Right? Okay. Yes. Okay. Next question is correct order of basic strength of pyrrole, pyridine and p-pyridine. Okay. So now as you can see here, this is having 1, 2, 3, 4, 5, 6. Acha, basic strength, na, they are asking you. Basic strength is dependent on the lone pair availability. More is the lone pair available, more is the basic strength. Okay. So here we know that lone pair are not at all available in pyrrole. So this is having least basicity. So pyrrole is least basic. So pyrrole is least basic only in 3 and 4th option. Now we have to answer between pyridine and p-pyridine. Pyridine and p-pyridine. Okay. So pyridine is still having some resonance with other electrons, right? It is having not at all zero resonance, it is having. And can you see one thing here, that here it is having 1, 2, 3, it is sp, what hybridization? It is sp2 hybridization. This is 1, 2, 3, 4, it is sp3 hybridization, right? We know that sp2 hybridized, right? It can actually, because it is more electron negative, right? This is sp3 hybridized, right? This is less electronegative. So what will happen here, right? These are the lone pairs, these are the lone pairs. Though this lone pair, as you can see here, wait a minute, this is pyridine. sp3 will make it, electrons will be more on that side, है ना? So maximum will be p pyridine, then you have pyridine, right? Because here the lone pairs will will stay here only. So answer will be your 4th, right? So that is p pyridine, then you have pyridine, then you have pyrrole. That will become the correct answer. Next is, how many questions? Not that many questions we have now. Okay, maybe 7, 8 more questions. 7, 8 more. Okay, chalo. Now, next is, everybody, for the given compound, the correct order of increasing PA. So, pKa. That means acidic character. So, first you have to know. Right? So, here guys, first is what you will observe here. I think we have done this question before, isn't it? Acha, this is ortho meta. This is at meta position. So, this will only show minus I effect. This will show minus I and minus M effect. That is the reason here it will take out electrons with more efficiency. So, B will have the maximum order. B will have the maximum. Then you will have D. That means pK will be opposite. D will have, B will be the minimum. B will be the minimum. So B is minimum. Wait a minute. Minus M effect. Electron, you are taking out the electron here, right? Chalo, firstly let us make it like this. B, then you have D. Okay. Now, I think from this and this, what should be? Chalo, we will see. We will see. Okay. Now this is minus, this is minus. Here you are donating the electrons with plus M. There is also minus I effect going on here. Here also you are donating the, this is the ortho and this is meta position. So at meta position you only have minus I effect, not plus M effect, okay? At meta position you only have minus effect, right? So this is ortho, this is meta. Para position you will have both. Here you will have no effect. Okay. That means in the end what you can observe, that this is minus, this total is having maximum minus. So it will be maximum acidic, right? Okay. Maximum acidic, I can just write it here, maximum acidic. Then you have plus M effect there. Then you have 1 minus, this is also minus I, na? This is also minus I, right? So also meta and meta positions, okay? So if you have to conclude between both of them, then you will have D after this, right? Okay, I'm getting a little bit confused here. This is B should be the maximum, why I have not written it here? Chalo. Let's firstly write our order here. B, then after that you will have D, right? Then here you have plus M. So plus M will make it unstable. Then you will have E here, right? Unstable, before unstable you will have A, minus I, arey yaar, minus I, B. then you have D, that is minus I. Okay, wait a minute, minus I, then you have D, minus, minus, both of them we have seen. This is plus M, this is minus I. There is no effect on that. So A will be here, okay? And this will be your plus M means D, sorry, E. And here you will have C. Wait a minute, let me see that again. B is having minus, that means it is maximum acidic. Then you have D, then you have C, which is showing you minus I effect, right? And then this one is showing plus M effect, so it is E, right? It is unstable. This is A. B, D, C, A, E. So it will be opposite. That will be E, or you can say B, D, C, A, E. B, D, C, A, E. B, D, C, A, E. So is first, it should be the correct answer. Yeah. Okay. Yes. Thank God. Okay. So A is the correct answer. Got it now? How I have done this? Okay. How I have done this? Got it? So basically, you just need to understand one concept here. If you know this concept, then you will get the answer right. If you don't know this concept, then you will get confused. Okay. So here, meta position. At meta position, it will only show minus effect. Okay. At para position, it will show plus effect. Usually, C and E is the confusing part here, where students do mistakes. Okay. So here, that's why 2 minus I, that is why maximum stable. Here, I have these two options, but I know that here still this NO2 group is electron withdrawing. I to know that, na? This is minus M. Though we don't prefer to write minus M here, but we know that this is more dominating. This is more electron withdrawing as compared to OCH3. Even minus I of NO2 is stronger as compared to OR, right? So that is why then you have D, then you have C, right? So this is sorted. Out of this E and A, we know that here you have no effect, then you have A. E is having plus M effect here. That is why it is E. So opposite order of P, K, A. So A is the correct answer. Got it? Chalo. Relative stability. Now next question is relative stability, right? Okay. Very good. Very good. Now, relative stability of contributing, I'll just write one thing here. Meta effect is not. Just write one thing here somewhere. Meta effect, meta position, on meta position, no mesomeric effect. Okay, this is the main key point of this question. That at meta position, there will be no mesomeric effect. Okay, that is the main key point. Okay. Next question. Oops. How come? Arey yaar, already showed you the answer. Chalo. So this is basically, I think this too we have done now. Na? This is a repeated question. A is first is neutral. That is why maximum. Then you have negative charge on oxygen. So second, then you have third. So first will be the correct answer, right? So repeated question it is. Next we have the correct stability order again. Correct stability order of the following resonance structures is. So let us see the resonating structures here. Beta, here they have written negative on carbon. Oxygen it is positive. Here on carbon it is positive. Here oxygen it is negative. Here it is neutral. Okay, here it is neutral. So the one which is neutral will be maximum stable, right? I think this is the same question only. Oxygen is having negative, so second. After that, you have first. 3, 2, 1. 3, 2, 1. So fourth is the correct. It's the same question with just options, just switching the options here. Okay? Yes? Okay? Okay? Yes. Now, fourth is the correct answer. Then you have, with respect to the following, with respect to the compounds 1 to 4, choose the correct statement. You have to choose the correct statement here. The acidity of compound 1 is due to delocalization in the conjugate base. They are saying that the acidity of 1, if you talk about, if you lose This hydrogen here, you will get one negative here. This negative is going to show double bond, single bond resonance. That means negative single bond, double bond, negative single bond resonance, negative single bond, double bond resonance. So 3 resonance it is going to show. The acidity of compound 1 is due to delocalization of conjugate base. That is true. This is a multiple answer question, okay? The conjugate base of compound 4 is aromatic. Compound 4, the conjugate base will be this thing. 1, 2, 3, 4, 5, 6. So it will be aromatic. This is also true. 6 pi electrons it will have. It will all be aromatic, right? This is also true. Compound 2 become more acidic when it has NO2 substituent. If you have NO2 substituent, it will withdraw the electrons. It will minus I, minus M, it will show, right? So it will make, when you are taking out the electron, you are making it more acidic. So this is also true, right? Next is the acidity of the compounds follows the order. That is, first is maximum, okay. Then you have fourth because of FsP, okay. Then you have fourth, okay, because it is becoming aromatic, okay. Then you have fifth, then you have second, then you have third. First resonance, wait a minute. Here you have to use this rule, that is Barhi. B-A-R-H-I, okay. For this you have to use this rule Barhi. Guys, firstly you have to see aromaticity. Aromaticity is present in fourth. So we will not see resonance. We will see aromaticity here, right? So aromaticity means fourth will be the maximum, right? Only one is aromatic here, that is the fourth one. So fourth will be the having the maximum stability. Okay, got it? Okay, yes, chalo. Now fourth will be having the maximum stability, so that is the incorrect option. So incorrect option is the right answer. That means A, B, C are the correct and fourth is the incorrect option. Okay, next you have consider the, they are saying consider the following 4 compounds 1, 2, 3, 4. Okay. Okay, try to answer this. The order of basicity is 1, 2, 3, 4. 2, 1, 3, 4. Okay. So if you talk about the order of basicity here, 2, 1, you have 2, this is 1. This is, you are donating more electrons here, so this will be more basic, right? Okay. As compared to 1, that is true. If you talk about this, you are withdrawing the electrons, you are taking out the electrons, so they both will be less basic. See, basicity is, just remember this thing, basicity is directly proportional to electron donating, inversely to electron withdrawing group. Okay, so here when you see this thing, 1 and 2, they don't have any electron withdrawing group, right? But this has electron donating group. That is why second is more basic as compared to 1. Third and fourth, they have electron withdrawing groups. That is the reason here when they will take out the electrons here, when they will take out the electrons here, what will happen here? Because of this lone pair here, because of this lone pair here, see, very important thing, 3 NO2 group, 3 NO2 group here. This is the important thing. This is the important thing. You will feel that, ma'am, here if I talk about 3 is more basic. How, ma'am? 3 is not more basic. The question will be in your head will be, because this is questionable, guys. This is questionable. In your head it will be, ma'am, why 3 is more basic as compared to 4? Ma'am, here we are taking out electrons. Yes, ma'am, that is true. Here also we are taking out electron. Yes, that is true. But ma'am, here we are donating the electrons also. We are donating the electrons also. Here no one is donating it here. So what will happen basically? Here you will have SIR. Steric interference you will have. Right? Steric hindrance, because of this R and R group, there will be steric hindrance, right? Because of this steric hindrance, right? This minus, this resonance, because of this steric hindrance, it will be very difficult for these NO2 groups to take out the electrons, right? Okay, it will be very difficult for these electrons to take out the electrons, right? Okay. Now, next statement is the magnitude of pKb difference between 1 and 2 is more than that of 3 and 4. Difference between these two are more as compared to these two. Okay. These two, they are saying the pKb difference is more as compared to these two. Resonance is more in 3 than 4. Resonance is more in 3. Steric effect makes compound S. Okay. So guys, see this. Okay. See this. Okay. I'll tell you what is the correct answer. First is these two options are very important. Okay. The options are itself the questions. Okay. First thing is they are saying this is the basicity order, right? Here, this thing is very questionable as I asked you, right? Here, this CH3 and CH3 group is a very big group. Because of this big group, it will affect that the NO2 groups here will not be able to take out the electrons because of this CH3 groups here. And that is the reason NO2 groups will show less resonance. So the third point, resonance effect is more in 3 as compared to 4 is the correct option, right? Because here, because steric hindrance, because of the steric hindrance of CH3, it will be difficult for these NO2 groups to show, this is a very, very important question, okay, to show the resonance, right? Very, very important. So this is true. Next is steric effect makes compound 4 more basic than third. Yes. The fourth compound, because NO2 group is not able to take out the electrons due to the steric effect. That is why resonance is less in fourth and hence it is not able to withdraw the electrons as compared to this third compound. That is the reason fourth is more basic as compared to third. So this will become the false. This will become true. Now what about the second point? The magnitude of pKb difference between 1 and 2 is more. See here, because of the steric effect, the magnitude, the difference will be so large, right? The basicity difference will be very large because of this bulky groups here, right? So this statement is also false. This statement is also false. So answer is C and D are true. Okay? Okay? Chal. Next is the correct order of acidic strength of the following carboxylic acids. For the carboxylic acid, which is the correct order of acidic strength, guys? What is the correct order of acidic strength? If you talk about this thing here, it will be CH triple bond CO, wait a minute, C, then this is COO negative. Here it is C double bond, this is CH2, this is COO negative, this is benzene, MEO, OMe, right? OMe, right? This is COO negative and here it is CH3, CH2, COO negative. But as you can see here, this is having sp hybridized. This is also sp. This is sp. This is sp2 hybridized. 1, 2, and there will be one more hydrogen over here. Right? 1, 2. This will be one more hydrogen over here. Right? This is sp. This is sp2. Now, here as you can see, between these three things, if you talk about this is your sp. This is sp3 hybridized. This is having the maximum electronegativity. So out of 1, 2 and 3, we know that first is going to be maximum acidic, right? It is going to be having the maximum acidity out of 1, 2, 3. So answer will be 1, then 2, then you will have 3. 1, 2, 3, 1, 2, 3 is here. So this will not be the answer. 1, 2, 3. So this will not be the answer. 1, 2, 3. So answer to we got it only, right? So D. Now, what about this one? What about this one? Here you are donating the electrons with the help of mesomeric effect, plus M effect. Here you were showing minus I, minus I, minus I. Here you are showing plus M. So you're donating, you're making it unstable. So that will be least stable here. Answer will be D. Okay? Chalo. Next question is choose the correct option here. Choose the correct option that gives an aromatic compound in the products. Okay, so firstly let us see the reactions here. The reactions are like this. First compound is going to give you something like this. Okay, it is going to give you this compound which is having 4 pi electrons, which is anti-aromatic compound. Next is these reactions, guys, we have already done. Okay, so I will not going to explain these reactions because we have already done these reactions. Okay, alcoholic QH. Alcoholic QH means firstly, so this QH is going to cause after NH2 two bases you are adding. So it is going to give you alkyne here, right? So it is going to give you this alkyne, that is triple bond alkyne. After red hot tube, you have a red hot iron tube, it is going to do aromatization, right? So answer will be mesitylene will be formed here. So now mesitylene is aromatic compound, right? This aromaticity, it is not going to give you aromatic compound, non-aromatic. Here when you have MEO negative, this is going to abstract the proton here, right? And the electrons will be donated here. You will have this, and this is your 1, 2, 3, 4, 5, 6 pi electrons. This is aromatic in nature. So answer is B and D are going to give you aromatic. So answer is B and D. This and this, they are going to give you the aromatic compounds. Okay. Next is among the following, the number of aromatic compounds that you will have. Among the following, the number of aromatic beta, maybe next 2-3 questions I feel. 3 questions we have. 3 questions we have. Okay, 3 questions. Among the following, the number of aromatic compounds. Number of aromatic compounds, guys. So this is not aromatic because it is 8 anulene. It is non-aromatic. It is having tub-like structure. So it is not aromatic. Not aromatic. It is non-aromatic. Right? 1, 2, 3, 4. It is anti-aromatic. So it is not aromatic. 1, 2. It is aromatic. It is 1, 2. It is non-aromatic. Right? So just apply cross here. This is non-aromatic. Non-aromatic. This is 1, 2, 3, 4, 5, 6. This is aromatic. Right, this is aromatic, no? Complete conjugation is also there. 1, 2, 3, 4, it is anti-aromatic. Right, so this is 1, 2, 3, 4, 5, 6, again aromatic. 1, 2, 3, 4, 5, 6, again aromatic. This is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2 rings are aromatic. Okay. 1, 2, 3, 4, 5. 5 are aromatic here. 1, 2, 3, 4 and 5. 5 are aromatic. Okay. So answer will be 5. Okay. Next is the correct order of the following compounds is. Again, a very, very important question. Okay. Because here you have the application of ortho effect. What is ortho effect? Ortho effect means that whenever you talk about benzoic acid, and this is only applicable to benzoic acid. When you have benzoic acid, you have any group at ortho position, whether it's electron donating group or electron withdrawing group, it will be more acidic. It doesn't matter, it is electron donating or electron withdrawing, it will be more acidic, right? Okay. Now, at ortho positions you have 2 OH. At ortho positions you have 1 OH. So that means first and second is going to be more acidic as compared to third and fourth. Right? Because of ortho effect. Here you can say that this is ortho effect. Ortho effect. I'm not even seeing whether it is plus I minus I, nothing. It is ortho, that means it is more acidic, right? Now, out of these two, which is more acidic? It is having hydrogen bonding here, okay? This is a very, very important question. This is also having hydrogen bonding. Because of two-sided hydrogen bonding, this COO negative ion will be more stable. Carbanion will become more stable because of the hydrogen bonding. And that is the reason first is more acidic as compared to second, right? Then now I have to choose between third and fourth. Third and fourth. Now I know that at third position, at meta position, I only have minus I effect, so it will be minus I. At para position, I can show both the effects, so it is minus I and plus M effect it is showing. Plus M effect is more dominating, so it will make it more unstable. So fourth will be more unstable. Then here you will have third. Got it? Got the concept? So 1, 2, 3, 4. So A will be the correct answer. Okay? A will be the correct answer. Got the concept here, guys? Okay? Ma'am, 8th compound is not completed. Wait a minute. Which 8th compound, beta? 1, 2, 3, 4, 5, 6, 7, 8. But I told you one thing. That whenever you have 2, 3 rings, now, so if you have only one ring out of those rings which is aromatic, the whole compound will be aromatic. So here I know this ring is aromatic. Here this ring is aromatic and this ring is aromatic. So it is making the whole compound aromatic. Okay? Chalo. Now, next question is, and the last question of today is very, very important. Again, it's a very, very important question, right? Okay? Try to draw the resonating structure yourself also. Number of resonance structure for N is, this is the N, they are saying that number of resonance structure. We know that after NaOH it will become this. If you leave this, this is where it will become the resonance structure. Very, very important. It will jump here. Then 2, 3 condition. It can also jump here, right? After that, I'll just show you the resonating structures here so that you're able to draw that yourself as well, right? This will be the compound firstly, right? Okay. So from here, as you can see, firstly, electron will jump here. Then this pi bond will jump here. This will be one negative here. There will be one double bond here. Right, there will be one double bond here, right? Okay, there will be one double bond here. Now, negative single bond, double bond. So, negative will jump here, double bond will jump here. You will have negative charge here and this will be the compound, right? After this, let's see. After this, there are two choices that it will have. From this negative, either it can jump to this side or it can jump to this side. That is why we have differentiated it. If it is jumping to this side, then this electron will be shifted here, right? So that is why one double bond here and one electron here. If it is jumping to this side, then one electron will be shifted here. So one electron here and one double bond here. Till here, is that correct? Till here, is that clear? Till here, is that clear? After this, this will have a different resonating structure. This will have different. This electron will jump here. This pi bond will jump here. Again, you will have this resonating structure. Again, this electron will jump here. This electron will jump here. Pi bonds will jump here. You will have this resonating structure. Again, this electron will jump here. This pi electron will jump here. Now, this is the same that you have went from, right? So, this was your initial stage only. What about this one? This electron will jump here. Again, you will have O negative here. That means you have to reach to O negative in the end from all the directions, right? And these will be your resonating structures that you will have. Now, guys, tell me, is the resonating structures clear to you or not? Is the resonating structure, or do you want me to draw that? Right? Okay. Okay, do you want me to draw those resonating structures? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9 resonating structure. This resonating structure is different. This is different, and this is different. Okay, these are different resonating. Here you have 3 bonds inside. Here you have 3 bonds outside. Here you have 3 bonds inside. Right? Here you have single, double, single. Here this is double, single, double. So these are different. Okay. Okay. Nahi yaar, you have to draw that. Okay. There is no formula. Right? Okay. So you have to draw the resonating structures. Okay. Yes. Chalo. Okay, beta. Is that clear? I want all of you to draw these resonating structure yourself. If you feel in the next lecture, ma'am, I was not able to do that, then I'll do that for you. Okay. Yes. Okay, beta. Any problem? Any problem? Now, before going, I have this offer for you where we are providing you the 3 test series plus JEE Mains previous year book that is just for 1999. The link is in the description. The third link is the booklet link, okay, where you will get the test series also, right? Everything will be delivered to you. Don't worry about that, right? So here you have physics, chemistry, and mathematics that will be available to you, where last 2 to 3 years of means 44 shifts, 1320 questions of those will be provided to you with the solutions, right? And test series will be provided to you, okay, at just 1999. Okay. Which is where you are confused, beta. So here what we are doing, basically this is a negative, it is shifting here, this pi bond is shifting here, that is why you have 1 pi bond here and 1 wait a minute, acha. Okay, so this one are you confused about? This is this is electrons, this is shifted here, and this pi electron is shifting here, so that is why you have pi bond here and O negative here. Okay, I think you are getting confused because you have just seen the structures. If you draw this yourself, this is actually not that difficult. Okay, this is very simple. Basically what you need to do is just need to rotate the electron over here. First it will go to this ring, right? To this way it will go for this thing, negative over here, then you will have negative firstly here, then you will have negative will jump here, electrons will jump here, then you will have negative here, right? So after that, either to this side or to this ring, right? So depending upon that, you will have different resonating structures. Okay. Yes. Chalo. Okay, thank you so much. Thank you so much, Aradhya. Thank you so much, Minhaj, Sachin. We will do that. Hai na? That's your task. Do that because what I'll just make the resonating structure in front of you. You'll again get confused, right? Try to do it yourself. If you're not able to do that, I'll do that in the next class. Okay? Yes? Chalo. Tomorrow there is any live that you have to see. I think there is one live of maths or physics. You will see that, right? And with chemistry, we'll see you on Thursday for isomerism. Okay? Chalo. Okay then. Bye-bye. Take care. See you all in the next class. Take care. Good night. Bye-bye.